Hello. If you're watching this, that probably means that you've tried the practice exam and there's maybe a few questions that you got, maybe you forgot how to do, or you tried them and didn't quite get the right answers, so you want to know what did you do wrong or what's going on there. So definitely feel free to fast forward this video until I get to the problem that you're actually, you're having a problem with, I guess. Don't feel like you have to watch the whole thing, because I have a feeling it'll be pretty long. But I'm just going to start at the beginning, just in case there's anyone that, had problems at the very beginning. So I'll just, might as well start with the first problem here. It's from section 1.1. There aren't a lot of problems from the chapter 1, but these are things, I kind of put these on here mostly because I think they'll help us with future problems too, So it's, if you don't know how to translate this statement into symbols and algebraic expressions, then it's going to be hard for you to translate word problems later on. So these are good to practice, even if maybe there won't necessarily be an exam problem exactly like this. But it will help, so it's good to practice anyway. But what does it say? It says, translate into an algebraic expression 4 less than x. So if you think about 4 less than something, I think we've talked about this before in the chapter 1 review video, but if you have 4 less than something, that means you're subtracting 4 from something. And then, of course, 4 less than what? Well, whatever follows less than would be the thing that you're subtracting from, so it must be x. So I think that works. 4 less than x means you're subtracting 4 from x. And of course, that's different than if you had switched them. 4 less than x, if you wrote 4 minus x, that's not quite right. Because of course, if you switch two terms in subtraction, that'll be a different answer. So that wouldn't work. It would have to be when you have 4 less of something, you're subtracting 4 from that thing, not subtracting that thing from 4. Okay, now we'll try number 2. This one's a little more complicated because it's not just an algebraic expression, it's going to be an equation. So it wants us to translate this into an equation. It says when 345 is added to a number, and I might even just stop there. When 345 is added to, just that right there means you're adding 345 to something here, and I'll just have to figure out what that is, to a number. And I guess when they say a number, that must mean the unknown number that we don't know. So you can call it, really, I think I called it x in the solutions, but you can call it anything you want. If you want to write n for number or a different variable, that's fine. Just don't feel like you have to write x, and if it's not an x, that doesn't mean you're wrong. So okay, when 345 is added to a number, so then they say the result is, so I guess the result, that part doesn't really tell us a whole lot, but if you remember the word is, that's code word for equals. I think we talked about that before in chapter 1. So that must mean that this is equal to something, whatever follows equals, and of course whatever's after the word is, and right after the word is the number 987, so that must be the equation right there. And I mean, by this point we know how to solve that, so it's kind of tempting not to solve it, but they say this is all they really want in their answer. They said no need to solve, just the equation's all we want, so that should be good. Alright, hopefully so far so good. Let's try number 3 here. So section 1.3, you can tell there are a lot more problems here, but it's because it's kind of dealing with all types of fraction operations. You can multiply, you can divide, you can add, you can subtract. So just kind of review there. So looking at number 3, we have 12 over 25 multiplied by 15 over 8. And we know that we can multiply across, but we know by now that it's easier to reduce first. So I'm going to look at what do I have here to reduce. I think the only reducing I can do is along the diagonal. Like I see here that 25 and 15, they're both divisible by 5, so I might reduce them real quick here. 15 divided by 5 is 3. 25 divided by 5 is 5. So that's one type of reducing we can do. On the other diagonal, I see that 12 and 8, those are also reducible by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. And I think that's all we can reduce. So even though there are 2 3's on the top now, 3 times 3, remember you can't reduce across, you can only reduce diagonally or vertically. So really at this point I have no choice but to multiply across. 3 times 3 is 9, And then 5 times 2 is 10. So 9/10 must be the answer to that one. Now we'll try number 4. So remember number 4, now that it's division, we know we need to multiply by the reciprocal of the rightmost fraction. But even before I do that, I realize that I'm dividing a whole number by a fraction. So I need to first make that whole number into a fraction, and then I'll think about how to divide the two fractions. But like we said, now we can flip the second fraction upside down, keep the first one the same, 12 over 1, and then multiply by the reciprocal of the second fraction, 4/9. Reciprocal would be 9/4. There we are. And now we can see if there's anything to reduce. The only thing I can reduce is along this diagonal. 4 goes into 4 once, 4 goes into 12 3 times. And if you multiply across, you're left with 3 times 9 is 27, over 1 times 1 is 1. But remember that anything over 1 as a fraction can be reduced to a whole number. Because think of this as like 27 divided by 1. 27 divided by 1 is just 27, so you might as well write the whole number 27. Alright, and that's that one. Now let's look at the next guy here, number 5. Of course, now that we're adding or subtracting, like number 5 and number 6 have, it's a lot more difficult because you can only add or subtract when they have the same denominator, right? So I have to think about, for number 5, what's the common denominator there? Between 10 and 15, what is their common denominator? It would be 30, right? Because 10 divides into 30 and so does 15, and that's the smallest number they both divide into. So I can see that, that's going to happen. The least common denominator here is 30. So I want to see what I can multiply the first fraction by to get 30, and then the second fraction as the denominator. The first fraction's denominator is a 10. I would have to multiply it by 3 to make that denominator 30. Then of course, whatever you do to the top, you have to do to the bottom. And then how about the second fraction? Its denominator is 15 right now. To make it 30, I'll multiply it by 2, top and bottom. Now we'll see how those kind of transform. Now the first fraction, if I multiply across, becomes 9/30. And then with the second fraction, if I multiply across, I have 16/30. And now all I have to do is add their numerators. And then, of course, if this fraction reduces, I'll try to reduce it. Okay, we have 9 plus 16, that's 25, over their common denominator of 30. But you notice that that fraction reduces by 5. And if I reduce both of those by 5, I end up with 5/6. That would be your answer for number 5 there. So far, so good. Okay. Oops, sorry. Let's try number 6. That's a good looking one. It's going to be really similar. You know, you have to find a common denominator and all that type of stuff. It's just when you're done here, you're not going to be adding like we did in the last one. You'll be subtracting the numerators. But really similar. So let me see. Between 9 and 12, those are the denominators. What's the LCD there? It would be 36, right? You know, I think for me the fastest way to think of LCD is what are all the multiples of 9, for example? 9 times 1, 9 times 2, 9 times 3, 9 times 4. It's kind of hard to think of how far to go. 9 times 5. You can keep going. And then do the same thing for the other denominator. What are all the multiples of 12? 12 times 1 is 12. 12 times 2, 24. 12 times 3. And then, of course, you're going to stop when you see the common one. They finally have something in common, 36. And you can, oops, sorry. You can kind of do that in your head, you know. You don't have to write that out like I did, but that's kind of in my mind. I'm looking, what are all the multiples of one of these guys? Okay, are any of those also a multiple of the other guy? That's usually a quick way of doing that, especially when the denominators aren't too big. So what would I have to multiply the first fraction by so that its denominator is 36? Well, right now its denominator is 9. 9 times 4 would be 36. So that's what I need to multiply that guy by. And that'll become 32 over 36. For the second fraction, I asked myself 12 times what is 36? Well, 12 times 3 is 36. So I'll multiply that guy by 3 over 3. It'll become 15 over 36. And if I subtract those, I end up with 17 over 36, which I believe does not reduce, right? Because 17 is prime, and nothing divides into 36 that also divides into 17. So I think we're done with that one. All right. Now for section 1.4, really all you have to remember is which of these means which? You know, this symbol, is that the less than or is that the greater than? Well, remember, if the little pointy part's pointing to the right, like that one is, that's greater than. That means the thing to the left of that symbol is greater than the thing to the right. Whereas the other symbol, when it's backwards, where the pointy part's pointing to the left, that means the left number is less than the right number. So basically, for number 7, for example, if you read this from left to right, from -5 to -8, which one's larger? Is it -5 is greater than -8, or is it -5 is less than -8? And especially with negatives, it's kind of tricky, because if it was just 5 and 8, I know 5 is less than 8, but for negatives it's different. Because if you look at those guys on the number line, -8 is actually to the left of -5. That means -8 is smaller, which means -5 is greater than -8. Yeah, so be careful, especially with negatives, because you think one thing and it might be the opposite. Alright, how about number 8? So I have 1.257, that almost looks like the same number as the other guy, 1.275. They've just switched these two digits. So which one's larger? Well, they're the same for the first couple digits, right? 1.2. So I have to look at the third digit there, the 5 versus the 7. So because 7 is larger than 5, the first digit they differ with, that means the number on the right is larger than the number on the left. Which means if you were to read this from left to right, you would say 1.257 is smaller than or less than 1.275. And then the last guy, number 9, 4 of course is greater than -1. That one's a little simpler, I think. Because on the number line, -1 is off on the left side, and 4 is on the right side of 0. So really, it's the greater one's going to be the one that's further to the right on the number line, as we've seen before. Alright, so I have a feeling you probably didn't have a problem with that one as much, as there's other ones on here that are a lot trickier. But if you did, it's probably just because you forgot which way the symbol, you know, when it's facing one way, what does that mean? When it's facing the other way, what does that mean? And then number 8 was a little tricky because those numbers look almost the same. They're just different by one digit. So how about section 1.5 here, number 10? There's only one problem, and I think it's because if you know how to do this one, then you'll know how to do any of these problems. They're all kind of the same. Looking at what we have, I see that there are only 2 terms here that don't have a variable attached. Other than the -7 and the 13, the other 2 variables have, or sorry, the other 2 terms have a variable attached. But the -7 and the 13, I can combine those to make 6. Those guys are like terms. And then the other terms, 10.5y and -11.5y, those are like terms because they both have a y attached. So I know my answer is going to have a y. I just have to add or subtract their coefficients. So I'm adding 10.5 plus -11.5. That makes -1. But as we've seen before, when you have a coefficient of 1 or -1, you can just drop it. Leave the sign, of course. If it's negative, keep it negative. But it's nice and simple that way. So this is a fine answer. Or you could have written the variable first. Either one's good. I don't know which one I prefer. I'd say there's kind of good things about both of them. For the first one, it's kind of nice to have your leftmost term not be negative, I guess. You'll see that a lot in math books. They'll switch things around. So the term that comes first on the left does not have a negative in the front. I think it's just because it looks nicer, or you won't miss a negative as you're reading it, I guess, maybe. So that's why that one's nice. But also, the second one's nice too, because like we said, we always want our terms in descending order of power. So I want my variable term, and then I want my constant term. So it's kind of good and bad about both of these, and I'd say it's kind of like a toss-up as to which one's better. So don't feel like one's better than the other. They're both good for different reasons, and yeah, you're fine with either one of those. How about number 11 then? Let's see, they give us this algebraic expression here, -100 divided by a squared. And they want us, basically they're saying substitute -5 where a is in that expression. So all I have to do really is rewrite the expression. It's -100 divided by something squared. But they want that something to be the number that they gave me, -5 for a. And now my job is just to simplify this down to one number. And of course, this looks like an order of operations type thing, which we'll see in a couple problems here again. So according to order of operations, the first thing I should do is parentheses. And which I don't really have any. I do see parentheses, but there's nothing to do inside those parentheses. All that's inside there is a -5. There's not really any operations to do. So I'll move on to the second thing, which is exponent. And there is an exponent. I better take care of that next. I'll leave everything else the same, the -100 divided by. But then I'm squaring -5, which means you're doing -5 times itself. -5 times -5 is +25. Alright, now I guess there's not a lot of choice left, huh? There's only division left. So it's what's -100 divided by 25? Well, 100 divided by 25 is 4. It's a negative divided by a positive, so it should be a negative in the end. So not too bad. As long as you're careful, you know, don't rush. I think that's the thing about these problems, 11, 12, 13, and 14. If you rush them, then I think it's easy to make a mistake. But if you're careful and you go slow, then you should be good. So how about number 12? Number 12 is going to be similar. It's just got kind of a more complicated look to it. So let's see about that guy. They want us to take this expression. I'm going to rewrite it with the x's missing. 3 times x minus 4 times x squared over x squared minus 20. And they want us to replace our x's with -2. And x occurred twice in the numerator and once in the denominator. So I have to replace all the x's with that variable, or with that number. All right, now I have to go back to order of operations. Are there parentheses? Yeah, but there's nothing to do in there, so I can skip that. Exponent, yeah, there are a couple exponents, so I'm going to rewrite everything that doesn't have an exponent as it is. 3 times -2 minus 4 times... All right, now we get to an exponent. It's supposed to be -2 squared. That means -2 times -2, which is +4. And then in the denominator, I have another -2 squared. Like we just said, that's +4. And then there's the -20 that was already in the denominator. Alright, and then what else is there left? The next thing to do is multiply. And since, you know, this is a big old fraction, I would want to simplify the numerator down as much as possible until it's one number. And then the same with the denominator. So I'm not really going to do any division, or I'm not going to make the numerator and denominator interact until the numerator and denominator are just one number each. So in the numerator, I see some multiplying. That's next. I'll go ahead and multiply those. 3 times -2 is -6. And then minus 4 times 4 is 16. So the numerator ends up being -6 minus 16. In the denominator, that's kind of obvious what to do. There's only one thing to do. 4 minus 20 is -16. Alright, so be careful here. Even though you see a -16 in the numerator and denominator, you can't cancel them. Remember, you can only cancel... I guess if that was all that was in the fraction, if this -6 wasn't there, you could cancel those 16s. But the fact that there are two separate terms in the numerator kind of forces you to have to combine those first and then try to reduce. So yeah, we will have to combine the numerator's terms first. -6 minus 16 is -22. And that's over the same denominator. And now, not only does that reduce a little bit, it's a negative over a negative, so it's going to be a positive. All I can reduce, though, is a little bit. 2 goes into both of those. 2 goes into 22 11 times. 2 goes into 16 8 times. So 11/8. That's not the nicest number in the world, but there it is. All right, now let's try some real order of operation problems here. Number 13. Okay. Let's see. We have some kind of, I think we talked about this before, but just to reiterate, you see parentheses and you see brackets in there. You can think of brackets as parentheses, kind of the same thing. So treat them just like parentheses. But since in order of operations, parentheses comes first, you might say, well, okay, if there's an inner parentheses here, but also there's this outer brackets, which we're treating as parentheses, what do you focus on first? Well, if there's two sets of parentheses, or brackets and parentheses, you want to really zoom in on the very middle part. Like if there's, if there are parentheses within parentheses, zoom right into the very middle. The middle parentheses is right here, the 5 minus 8. So I'd want to focus on that first. Let me subtract those guys, keeping everything else the same. it's bracket 2 times, see, 5 minus 8 would be negative 3. And then close bracket squared minus 12. Alright, but still, even though we've taken care of what's in the parentheses, because now there's just a negative 3 in the parentheses, which there's not much we can do with, but still, like we said, we're treating the brackets like parentheses. Yeah, they're only using brackets just so I guess you can differentiate the parentheses that were there and this new set of parentheses, so you don't get them mixed up thinking they're the same parentheses. So we're going to have to do what's in these brackets first before we do anything else. And inside the brackets, all there is to do is to multiply 2 times negative 3. That'll make negative 6. And then there's a square outside, minus 12. Alright, now we're finally done with the parentheses phase. The next thing to do is exponent. And I do see an exponent here. This is negative 6 squared. And again, you can treat the brackets like they're parentheses. Imagine this is, negative 6 in parentheses squared. Same thing. That means negative 6 times negative 6, which is positive 36. And now there is obviously not much left to do. We just have to subtract. 36 minus 12 is 24. So there we are. Okay, that was good. Yeah, like I said, I think the only thing you could do wrong here is go too fast, or I don't know, yeah. When people go too fast or they skip steps, I think that's when they really mess up on order of operations. So take your time. Yeah, take it easy. So let's try number 14. This one definitely looks more complicated. We'll just take our time and be careful with it. And like we said, since this is a big fraction, we're going to have to simplify the whole numerator as much as we can until it's one number, and then simplify the denominator as much as we can until it's just one number. So okay, let's see, in the numerator, I do see some parentheses, but there's not really anything I can do there. It's just a negative 2. So as far as order of operations go, I'm going to move on to exponent. And I see quite a few exponents here, actually. Negative 2 to the third, 4 to the second, and 5 to the second. You can kind of knock all those out at once if you want. The first one, you have negative 2 to the third. Remember, that's negative 2 multiplied by itself 3 times, which would be negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Would actually be what you end up with for the first term, plus, and then 4 to the second power, that's just 4 times 4, which is 16. So the numerator is becoming nice. The denominator, even though it's tempting, I'm going to try to hold off on multiplying 2 times 3 until later, because right now we're focused on the exponent part of PEMDAS. And here we have 2 times 3 minus, 5 squared. Notice it's not negative 5 in parentheses squared, so this isn't negative 5 times negative 5. It's a negative, and then just 5 times 5. And 5 times 5 is 25. Plus, and I'm going to leave the 3 times 7 for the next step. Alright, now that we've kind of done all we can as far as exponents go, the next thing to do is do any multiplication. In the numerator, there is no multiplication, so I'm going to just kind of leave it the same and figure out what's going on here later. In the denominator, there's 2 times 3. I can do that. That's 6. And then minus 25 plus, here's another set of multiplication. 3 times 7 is 21. Okay. And the next step is to divide, but I don't really see any division as far as, there's no division in the numerator, there's no division in the denominator. I know that this big fraction bar is like a division sign, but because they're, I don't know, it's kind of like the terms are separated, or the numerator and denominator are separated. You have to simplify the numerator until it's one number, same with the denominator, and then we can combine any like terms or reduce or whatever it is. So really now all that's left is adding and subtracting. So I'll just add and subtract from left to right. In the numerator, negative 8 plus 16 is 8. And the denominator I have 6 minus 25, that's negative 19. Negative 19 plus 21 is 2. And then I'll be left with 8 over 2, which reduces to just the whole number 4. Which is a really nice answer. I can't believe how nice that was. Alright, so if you got either of those wrong, I'd say it's probably just, like I said, because you skipped steps or you tried to go too fast. So take your time on these problems. It's definitely worth it. Okay, what's next? Now we're on to chapter 2, finally, huh? Chapter 2, okay. This is where we have actual equations, and before they have us solving equations, they just want to kind of warm us up a little bit. Like if we have an equation, as in number 15 here, 2/3 t equals 12, do we know how to tell if a certain number is a solution? For example, 8. Is t equals 8 a solution? And once we're done determining that, is t equals 18 a solution? Well, first we'll look at t equals 8. And just like you would even guess to do, you would just substitute 8 in for t and see if the statement is true or false. So okay, I'm going to replace t with 8. It's 2/3 times 8 equals 12. So if you end up with 12 equals 12, then it's a yes. But if you end up with anything other than 12 equals 12, it's a no. So if I try to multiply or to simplify the left side, I'm going to need to put the 8 over 1. And if I multiply 2/3 times 8 over 1, nothing reduces. All I have to do is multiply across there. 2 times 8 is 16 over 3 times 1 is 3. And 16 over 3 does not reduce. And 16 over 3 is not equal to 12. So the answer is no. T equals 8 is not a solution to this equation. Well, let's try the other value. They also gave us, at the end, they said, okay, well, after you're done checking 8, let's try 18. Is that a solution? So now we'll do the same thing, but with t equals 18. So I have 2/3 times t, but I want to see if 18 is a winner here. Is equal to 12. Okay. So I'll do the same thing. I'm going to put the 18 over 1 and try to reduce. It does reduce, actually. The 3 can go into the 18 6 times. If I multiply across, I have 2 times 6, which is 12. That's true. So that meant that t equals 18 is a solution. Yes, it is. That's good. I figured one would be and one wouldn't be, right? That's usually the way it goes. Not always, but a lot of times. Alright, now you can tell that the entire rest of this page, every single problem is just solving for a variable. And if you've gotten ahead in this class, like if you're a couple videos ahead or something, then this might look really easy to you, because you're, like I said, you're ahead. But remember, these used to be difficult for us, so it's hard to remember that a long time ago. We'll just go in order, though. Let's try number 16. So it wants us to solve 12 equals -7 plus y. So to solve it, all we need to do is isolate y. And since you see a -7 adding with y, I'm going to do the opposite. Opposite of a -7 is a +7. So I'll add 7 to both sides. And that should cancel it. And that's true, because -7 plus 7 is 0. That means if you want to be really careful and write out all your steps, which I don't expect you to write this, but -7 plus 7 is 0, and you have the y also. On the left side, 12 and 7 makes 21. Or 21, 19, what the heck? I'm losing my mind. 19, okay. And then, of course, 0 plus y is y. Anything plus 0 is that thing. So yeah, your answer would be 19. 19 equals y, or y equals 19, whichever way you want to say it. So pretty good. Okay, let's try number 17. This one looks a little scarier. I think the idea is the same. It's just now we have fractions. So it's up to you. You know what you could do is isolate m by adding the 2/3 over to the other side. Or we've seen a trick where if you see fractions, especially more than one fraction in your problem, and you kind of wish they weren't there, remember you can always multiply by the LCD to get rid of the fractions. So it's kind of up to you. You don't have to do that. If you don't mind dealing with fractions, then I guess don't worry about it. But just for fun, I'm going to do that, I think. So let me rewrite it one more time to give myself some room. -2/3 plus m is -3/4. And the LCD, okay, if I think about those two denominators, 3 and 4, the least common denominator would be a 12. So I want to take 12 and multiply it by every term, the 2/3, the m, and the 3/4. And you got to be careful, though, and maybe I'll write it really carefully. I'm going to write, especially if this is on an exam, I'd be really careful. It couldn't hurt to take an extra step just to make sure you're doing it right. 12 times the first fraction, I'm going to write that out and see what happens there later. And then 12 times m, of course we know what that means, 12m. So that one's not a big deal, I guess. Equals, and then 12 times the final fraction. let's see, 12 times the second, or the fraction on the other side, negative 3/4. Now I have to put the 12s over 1, especially when they're multiplying by a fraction. And then I'll try to reduce. Here, 3 can go into 12 4 times. And if I multiply across there, 4 times negative 2 will be negative 8. Plus 12m is, and I can reduce these guys, 4 can go into 12 3 times. 3 times negative 3 is negative 9. Alright, now this looks like a lot nicer equation to solve. If I want to solve for m, I'm going to move the 8 over first. If I add the 8, what's left is just 12m equals negative 1, since negative 9 and 8 makes negative 1. And the last step would be to divide by 12 to isolate m entirely. So m must be negative 1 over 12. That doesn't reduce. That's as good as that guy gets there. And maybe just in case, what if you did that problem a different way? What if you just kind of said, you know what, I don't mind dealing with fractions. I'm just going to isolate m from the beginning. Maybe we can think about how that would look. Let's see. If it was, from the beginning, it was negative 2/3 plus m equals negative 3/4. Okay, if you just wanted to isolate m kind of the old-fashioned way, since it's a negative 2/3 on the same side as m, I'd have to add that to the other side to move it. And then m would be all by itself. It would be m equal to what was already there, negative 3/4 plus 2/3. And of course, to combine these, you need a common denominator. So that's kind of the downside, I guess, of this method, but it's not too bad. Between 4 and 3, the common denominator would be 12. So the first fraction, what would I have to multiply his denominator by to make him a 12? He needed 3. And the second fraction, I would need to multiply by 4 to make his denominator a 12. So let's see, that'll become negative 9/12 plus 8/12. And if I combine their numerators, that's negative 1/12. So I'd say, I don't know which method's better or easier. They're probably about the same, I'd say. Just kind of depends what you don't like more. Which one seems more difficult or easier to make a mistake on. It's good to have seen both, though, because I think in the future both will be useful. Alright, that was number 17. How about number 18? This one almost looks too easy, huh? Like, wait, after that last one, what's going on? Why is this one so nice? It's just 6x equals 72. If I want to isolate x, the best way to do it is get rid of the 6. And what's 6 doing with x? Multiplying. So I'd have to do the opposite to get rid of it. And divide by 6. So x is 72 over 6. And I think this isn't obvious, but 6 divides into 72 evenly, so this will be a whole number. 6 can go into 7 once, with 1 left over. If I could bring down the 2, 6 goes into 12 2 times. So it looks like 72 over 6 is 12. That would be your answer there. Nice. Not too bad, not too bad. Alright, that was number 18. Let's see about number 19. That guy is over off to the left here. So number 19, at first glance, I thought, oh, you know what, this looks like it's already solved almost. Because the z is almost already by itself, right? But it does have a z with a negative in front. So my job is really just to get rid of the negative. And what would I do? I guess it's up to you. You can either multiply both sides by negative 1 or divide both sides by negative 1. It doesn't really matter, but I'd say if you have a choice, like we said, you could do either one, multiply or divide both sides by negative 1. In this case, it won't really matter either way. It won't be easier one way or the other. But I think what I'd do is try to get in the habit of multiplying, because that might, for more complicated problems, multiplying by negative 1 is easier to simplify than dividing by negative 1. So we'll actually see that later in this review, I think, for one problem later. So I think I'm going to multiply both sides by negative 1 now. Although dividing would be fine too. That way on the left, negative 1 times 42 is negative 42. Negative z times negative 1 is positive z. So there it is. Z must be negative 42. Okay, not bad. Let's try the last one from section 2.1. So we have negative 3/4 x equals 27. So this is one where it could be easy if you remember kind of the shortcut, or it could be kind of tedious if you don't. But remember, the best way to get rid of a fraction coefficient is to multiply both sides by the reciprocal. So if it's been a while, then don't worry, it's fine if you forgot that, but that's the easiest way to do it. Fraction coefficient. Yeah, and remember the reciprocal, you keep the same sign. So when I look at negative 3/4, his reciprocal is upside down 4/3, but it's still negative. So don't change the sign, it stays the same. The reciprocal of negative 3/4 is negative 4/3. I'm going to take that and multiply both sides by it. On the left side by negative 3/4 x, and then on the right side by 27. And you see the genius of that, because the 4's cancel, the 3's cancel. It's a negative times a negative, so it ends up being a positive, just x. And then on the right side, I have to put that 27 over 1 in order to multiply. And it actually reduces first. 3 goes into 27 9 times. So we end up with negative 4 times 9, which is negative 36. There he is. Beautiful. Not bad. So you could have, instead of multiplying both sides by the reciprocal of the fraction, you could have just divided both sides by the fraction, but you'd end up anyway having to flip and multiply, so this just kind of cuts out a step or two if you happen to remember it. If you don't happen to remember it, not a big deal. You're just taking an extra step later. I don't know if that's that big a deal. Alright, now we're into section 2.2, I believe, right? Yeah. So that was number 20. Now let's look at number 21. This one, if you remember from section 2.1, we were kind of tackling the simplest problems where isolating the variable only took one step, either adding or subtracting something from both sides, or multiplying or dividing something from both sides. But this section kind of introduced the problems where you have to do both, maybe add or subtract, and then multiply or divide. So that's why you see a kind of two-step process in these problems. But of course, if you have something adding or subtracting, and something multiplying or dividing, like we talked about, you want to get rid of what's adding or subtracting first. You have to. And since I see a 3 adding, I'm going to move him over first by subtracting him. And then 4x will be all by itself. On the other side, negative 21 and negative 3 makes negative 24. And the last step would be to get rid of the 4. And since 4 is multiplying by x, I'll do the opposite and divide both sides by it. Alright, that way x is negative 24 over 4 would be negative 6. Okay, good stuff. I think we're good. And of course, you know, in any of these problems, especially if you're taking a midterm or something and you have extra time at the end, you might want to be safe and check your answer. So you could always replace, you know, in the original problem, 4x plus 3 equals negative 21. Take your solution that you think is your solution and substitute it and see if you get a true statement. So this is me checking. It's totally optional. It's not like I'll mark you down if you don't check, but I would say I'd be mad at myself if I got these problems wrong. Like, I knew all the right steps, I just did something silly wrong. This will kind of catch you if you think you might have made a mistake. Okay, but we got the right thing. Negative 21 is negative 21, so I must have done that one right. Alright, now let's try number 22. This one looks more complicated. So I have something to distribute. Might as well do that first, huh? I think whenever you have something to distribute, it's a good idea to go ahead and do that. Yeah, because once I distribute, then there'll be no more parentheses left. And it's easier to solve for a variable when it's not trapped inside parentheses. So if I distribute, I have 3 times 5 first, that's 15. 3 times 3m is 9m. And then there was already negative 8 on the same side, equals 7. And now we have a few like terms. 9m doesn't have a like term, but 15 minus 8, that makes 7. Alright, now if I try to isolate m, the next thing I want to do is move the 7 over. Like we said, you always want to move the thing that's adding or subtracting first, and then the thing that's multiplying or dividing. So now we're just left with 9m on the left, actually 0 on the right, huh? Because 7 minus 7 is 0. The last step would be to divide by 9. Since we want to get rid of the 9, and it's 9 times m, we'll do the opposite. And 0 over 9 is 0. Remember, if you're doing 0 divided by something, that's 0. If this was upside down, like 9 over 0, that would be undefined. So it's fine to divide if 0's in the numerator, but it's not fine to divide if 0's in the denominator. Okay, now number 23 we have, it's even more complicated. There's a few things to distribute. I'm first going to distribute this 2 into these parentheses, and then I'll distribute this negative into these parentheses. What'll that change it to? It'll become 6t plus 2 minus 5 equals t, and then if I give the negative to the t inside, it'll become negative t or minus t, and the negative on the positive 2 will make it a negative 2 or a minus 2. And now there are some like terms on the left. We have 6t, and then 2 minus 5 makes negative 3. On the right, t minus t is 0. They cancel each other. So you're just left with that negative 2 that was already there. And now if I want to solve for t, I'm going to move the 3 over first by adding it, since that's the opposite of what it's doing right now. And 6t will be all by itself. It'll be equal to negative 2 plus 3 is 1. Now if I isolate the t, I'll divide by 6, and that'll be the winner. T must be 1/6. Alright, that one's not as easy to check your answer. So this one, you know what, I think for me, when I get a fraction answer, if I think, ooh, do I want to check that? It doesn't sound very fun, because imagine having to put a 1/6 here, a 1/6 here, and a 1/6 here. That's not pretty. So I think if I get a fraction answer, sometimes I just try the problem all over again, you know, to check my answer. And if I end up with the same, I'm probably doing it right. But you could check the long way. It would be kind of painful, though. Alright, let's try number 24. This one looks sort of similar. It's got two things to distribute. We have a negative on the left that needs to be distributed, and a 2 on the right that needs to be distributed. What do we get? 13. The 2c will become negative, and this 2 will also become negative. And if I multiply the 2 inside the right side of the equation, 2c plus 2 times 2 is 4, and then plus the 3c that was already there. On the left side, there are a few like terms. 3 minus 2 will make 11. And then the minus 2c doesn't have a like term. On the right side, we have 2c and 3c are like terms. They make 5c. Plus the 4. Alright, now we have a variable on either side. So this is where, I think the first time in all these problems where we have to get the variables together. It doesn't really matter which side you bring them on, but I think we've said whichever side has a smaller coefficient. This guy's got a negative 2, and this guy's got a 5. Definitely negative 2 is smaller, so I think I'll add him over to get the c's together. That way, negative 2c plus 2c is 0. That disappears. The c's on the right can combine. 5c plus 2c is 7c. And all that's left on the left side is the 11. On the right, the 7c that we wrote plus the 4 that was already there. Alright, now we're in a better place to actually solve for c. I'm going to try to isolate c first by moving the 4 over. Since it's a plus 4, I'll subtract and get rid of it. On the left side, I have 11 minus 4, that's 7. And then on the right is 7c. And to solve for c altogether, I'll divide both sides by its coefficient, 7. 7 divided by 7 is 1, so you end up with just c equals 1. That seems like way too nice of an answer, huh? Oh well, that one I wouldn't mind checking, you know, actually plugging that in, because that's a nice number. If it was a fraction, though, yeah, it might be just easier to try the whole thing over again, sadly. Okay, now let's try number 25. Ooh, this one's got a bunch of decimals, huh? It's kind of similar in a way to the problem we saw above had a bunch of fractions. Remember, you can get rid of decimals by either multiplying the whole equation by 10, 100, 1,000. Kind of depends on how many times you want to move the decimal over. But I only see one digit beyond the decimal in these two numbers. So all I really need to multiply by is 10. And that should get everybody to become a whole number. The tricky thing too is here you're thinking of, okay, 0.8 is one term, but then this 4 times b minus 1 is one entire term. So there's really only a need to multiply 10 by that term once. I'm not going to distribute the 10 onto the 4 and then the b and then the 1. It's just, this is all one item, so it only gets one 10. And 0.2 gets its own, and then same with this guy here. 3 times 4 minus b, that's all one item, so it only gets 1 10. So let's see, what will happen when I distribute? 10 times 0.8, we just move the decimal to the right once, it'll become 8. And then minus 10 times 4 is 40. And the b minus 1 doesn't get the 10. I guess it kind of gets the 10 in that instead of being multiplied by 4, it's now multiplied by 40. So it is going to kind of get that 10. Excuse me, it's just in the next step it'll get that 10. And now we've got 10 times 0.2. That moves the decimal to the right once to make it a 2. And then 10 times 3 will become 30. And of course, like we said before, we'll leave the rest the same because it kind of gets the 10 when I distribute this 30 in here. Alright, now we'll do the distributing. And think of it as not just 40 times these things, but negative 40. Negative 40 times b is negative 40b. Negative 40 times negative 1 is positive 40. On the right, I have 2 plus. 30 times 4 is 120. 30 times negative b is negative 30b. Okay, what kind of like terms do I have now? 8 and 40 is 48. And then minus the 40b equals 2 plus 120 is 122. And then minus the 30b. So similar to the last one, now we have to get the variables together. So look at their coefficients. We've got negative 40 and negative 30. Even though 30 is smaller than 40, negative 40 is smaller than negative 30. So I'm going to move the 40b over to the right. Although if you move the 30b over to the left, you're going to get the same answer either way. I think I just said move the smaller to the larger side because in the future that'll be easier. So it's good to get in that habit now. But don't worry if you did it the other way, it's fine. So those 40b's cancel, 48's all by itself. Equal to 122, and that'll become positive 10b. Because negative 30b plus 40b is 10b. And now we can isolate b by first subtracting the 122 to the left side. Let's see, 122 minus 48. That would be 74, but negative, huh? Negative 74. Yeah, because the larger number is negative. That means the result's going to be negative. Equals 10b. And the last step will be to divide by that 10. And I know I'm not excited at first. I say, oh man, 10 doesn't go into 74. But I know when you divide both sides by 10, all that happens is the decimal moves over to the left once. So 74 is a whole number. It has an invisible decimal at its right side. When you divide by 10, it just moves the decimal to the left once so that it becomes negative 7.4. I guess kind of like the opposite of multiplying by 10, right? That's the whole point of why we multiplied by 10 to begin with. So we can move the decimal to the right. So when you do the opposite and divide by 10, it's going to move the decimal to the left. Alright, let's try this last one here, and then we'll move on to the next page. 26, alright. We have a terrible fraction. I don't like that guy. 3 halves, and then another fraction on the right. Ugh. This might be one that's so complicated that I probably would multiply both sides by the LCD to get rid of those fractions. So between the denominators 2 and 6, the LCD would be 6. So I'm going to take that and multiply the entire equation by it. Let's see, I'm going to rewrite it one more time. 1 equals negative. Okay. So it looks like there's a lot going on here, but this is only all one term, the 3 halves 2x plus 5. So I really only need to multiply 6 by that whole term once. And then multiply 6 by the negative 1, and then multiply 6 by the last fraction. And just to be safe, I'm going to just first write 6 next to each of those guys. Especially the fractions, 6 times something, 6 times something. So 6 times, the first fraction was 3 halves, and then 2x plus 5. I think I can do this part though. 6 times negative 1, that's negative 6. Okay, I can handle that. And then 6 times the right fraction, I'm going to write that out. 6 times negative 5/6. And kind of think about how that looks. Oops, sorry. To simplify that, I'm going to have to take those 6's, the red 6's, and put them over 1 to try to reduce. On the left part, I see that 2 goes into 6 3 times, and then 3 times 3 is 9. That'll need to be distributed into these parentheses, minus this 6 that's just kind of waiting to see what happens with everybody else. On the right side, the 6's just cancel outright to leave negative 5. All right, now I think it's a lot nicer. There's no more fractions. I'd much rather deal with this problem. All right, first I'll distribute the 9 though. It'll be 18x plus 45, and then the minus 6 that was already there. If I combine these like terms, 45 minus 6 is 39. All right, if I isolate x, I'm going to have to subtract the 39 first. That'll leave me with 18x equals negative 44. All right, now I almost have it. I just need to divide by 18 and I'll be all done. All right, I know 18 doesn't go into 44 evenly, but that probably reduces. It's a negative divided by a positive, so it's a negative. I think only 2 goes into both, huh? That's sad. 2 goes into 44 22 times. 2 goes into 18 9 times. So your answer is negative 22 ninths. That's not that pretty, huh? Okay, now let's look at these formulas from section 2.3. So I have a few formulas. It's kind of the same idea, but instead of solving for the variable, you're solving for a certain variable, and there are going to be other variables kind of hanging out. So for number 27, we have 5x minus 4y equals 8. The first thing we're going to want to do is the whole thing is isolate y. So what I need to get rid of is this 5x and this negative 4. Because if those were gone, y would be by itself, and that's exactly what I want. So I see there's something adding or subtracting with y, the 5x, and there's something multiplying by y, the negative 4. But like we talked about in the previous problems, anything adding or subtracting with your variable you want to get rid of first. The thing that's multiplying or dividing you'd want to get rid of last. Sorry. So 5x minus 5x, if I get rid of that guy, then negative 4y is all by himself. That's good. On the right side, you could write 8 minus 5x, like, oh, 8 was there first, and now I'm subtracting 5x. Or you could have written the negative 5x first and then the 8. Doesn't really matter, just totally up to you, whatever you want to write. I wouldn't say one's better than the other at all. And now if we want to isolate y altogether, y is being multiplied by negative 4. If I do the opposite and divide both sides by it, that should get rid of it. And I think that looks good. So now y is all by itself. It's equal to 8 minus 5x over negative 4. And you could write it like this. The numerator, like we said, is negative 5x plus 8. So it doesn't really matter what order the terms on the top are in. But the only thing is, like we talked about before, if you ever see a negative in the numerator or the denominator, you'll probably see them pull it off to the side. So you probably see a negative and then the fraction. So I kind of took the negative from the 4 and threw it off to the side of the fraction. You probably see that more typically. This answer's fine too, it just looks better. So this one's good. You get full credit for this, but this one would be like, yeah, big old smile. Good job. You're awesome. All that type of stuff. All right, now how about number 28? This one looks kind of similar. Sort of, because there are 2 variables. And they want to solve for one of them, so kind of... Oh no, there's 3 variables. Ooh, I didn't see x. You tricky son of a gun. 3 variables. Ooh. Okay, calm down, huh? And you want to solve for n. Okay. So this one we have a few choices. The question here is kind of like to distribute or to not distribute. That is the question. And it's up to you. You could distribute. You don't have to. Maybe I'll do it both ways, because just in case you did it one way and you want to see if you did something wrong or whatever. First, though, I didn't distribute because you're trying to get n by itself. So I think there's no point of distributing the 5. It's just going to kind of make everything messy. I'm going to try to move everything over, 19, the 5, and the x. You know, I think if I leave the 5 outside and not distribute it, it's kind of like, it's easier to get out of the way. Let's see, I think we talked about this before in this section of the notes. We said, if you're trying to get rid of a bunch of things like we are, try to get rid of them the further they are from your variable. So right now, I'm trying to solve for n. What's the furthest thing from n on the same side of the equation? It says 19. That's really far away, so I'm going to move him first. Since he's positive, I'll subtract him. That way on the left we have m minus 19. On the right, the 19's gone, and the negative 5 is left times x minus n. Alright, now what's the next furthest thing from your variable n? I guess the negative 5, huh? He's kind of outside the parentheses. And he's multiplying, so I can do the opposite and divide both sides by that guy. If I divide both sides, it'd be m minus 19 over negative 5. equals, on the right you're just left with what was in the parentheses, x minus n. Okay. Now, every step I have to remind myself, what am I solving for? Is it x? Is it m? Is it n? Oh my gosh. No, this time it's n. Okay. That's why if you see me keep highlighting it a different color, I'm reminding myself that's what I'm solving for. So the next thing I would want to get rid of is this x. Since x is positive, I'll do the opposite and subtract it. That way it's that terrible fraction we started with, m minus 19 over negative 5, and then minus x. And then this is where I thought I was done. I say, oh, I'm done. Oh, but wait, it's not just n by itself, it's negative n. Now I've got to get rid of that negative, dang it. But this is where in a previous problem, remember I said, if you're trying to get rid of a negative, it's up to you if you want to multiply both sides by -1 or divide both sides. But it's usually, when it gets to more complicated problems, it's better to multiply. And this is an example like that. So I'm going to go ahead and multiply both sides by -1 over here, and then over here. Since there's two terms on the left, I'll have to multiply both of them by the -1. So that -1, it'll kind of make the fraction negative. So it'll be like a negative, and then m minus 19 over -5. And the -1 times the negative x will make it a positive x. And the negative n times -1 is positive n. So this is a perfectly fine answer here, but I do notice, if you notice, let's see, you have a negative outside and a negative on the bottom. Those two negatives will cancel, because you could, I guess, think of it as, I'm going to pull the negative from the bottom off to the side, like we did in other problems, right? I'm going to take this negative and put it over here. Then it'll become a negative, which is a positive. So you could write positive m minus 19 over 5 plus x. That would probably be simpler, because these two negatives would cancel each other out. Yeah, but let's say, okay, if that's fine with you and that's the way you went about it, or it makes sense to you, then you can skip what I'm about to do, kind of fast forward. But what if you were the type of person that wanted to distribute the 5? And that would work too. Let me try that and see how that goes. The answer might look a little different, so just so you know, if you didn't get the answer that I just circled, maybe it's just because you you went about it a different way, but that doesn't mean it's wrong. So let's try it the alternate way. Starting from the beginning, you know, I'm going to go ahead and distribute the 5. And you have to think of it as a -5. -5 times x is -5x. -5 times -n is positive 5n. Alright, yeah, so this might look a little different, the answer, but the answers are equivalent. So now if I want to solve for n, I guess I have two things here to get rid of. I'm going to move the 19 over first, maybe, because that's the furthest thing from n. So m minus 19 equals -5x plus 5n. And the next thing I think I would get rid of is this term that's adding with 5n, the 5x. Since it's a -5x, the opposite of that is adding 5x. And that way I have three terms now on the left. M minus 19 plus 5x. Now that's equal to what was on the right side, 5n. Now the last step would be divide by 5. And that would be it. So your answer looks a lot simpler when you do it this way, huh? It's m minus 19 plus 5x all over 5. That's equal to n. There we go. And you cannot cancel those 5s, unfortunately. You have to leave it like that. You can only cancel those 5s if every single term in the numerator had a 5 in common. But m doesn't have a 5, and neither does 19. So if you're thinking, you know what, that answer looks totally different than this red answer that you wrote over here. You know what it is? If they're actually the same, if you were to try to get a common denominator, like if I put this x over 1 and got a common denominator by going 5, 5, you know, I would end up with this answer. So they really are equivalent. It's just they look a little different, that's all. Okay, now we're on number 29. This one looks really simple, but I think it is really simple if you remember the trick. But if you forget the trick, it's not easy. So this one, it's capital A equals lowercase a t plus bt. So notice they're wanting us to solve for t, and you see t twice here. So the trick is, when you see your variable twice, you can't just isolate one of them. It's not like I can isolate this t, move everything else over. I have to get both t's together on one side, and then isolate them so that there's no t on the right side. So keep in mind, when you solve for a variable like we're doing, your answer cannot contain that variable. If you look at your answer right now and it contains a t, like t equals something with a t in it, it's wrong. You can't have that. So the trick is, we've talked about this in the notes for this section, but that's been a while probably. But if you want to isolate a variable that occurs in more than one term, in more than one, we have to factor it out. There's really no other way to go about it. Sadly, it's not like there's another way and this is the way I'm telling you to do it. This is the only way to do it. So we haven't seen this yet in this review packet, but yeah, this is the first time. Let me see, I have to factor t out, so if I think of AT and BT, they have a t in common. So it's almost like someone had did some distributing. I have to undo it. So it's like there was a t outside. What did they distribute the t onto? It's like t times what is AT, that'd be A. And then t times what is BT, that would be B. And you can always check to make sure you've kind of factored it out right. If I distribute that t back in, t times A, that's AT, yeah, that's true. T times B is BT, okay, yeah, I did it right. And now that I've kind of factored the t out, now if you think about it, there's only one t to isolate as opposed to two that I started with. And now I can isolate t in one step because it's t times this whole thing. If I want to get rid of this, I'll divide by it, a plus b on both sides. That'll cancel it, yeah, because on the top you have t times a plus b. If you divide by it, that should get rid of it. So capital A over lowercase a plus b. And now notice our answer does not contain a t. Your answer, which we got capital A over lowercase a plus b, cannot contain the variable you're trying to solve for. That would mean you did something wrong. You didn't do it right. So be careful on that. Yeah, if you see your variable twice, make sure you remember factor it out. All right. Let's see, now number 30. Number 30 is kind of silly. It's one of those ones, it's just kind of an excuse for them to have you use a formula. That's pretty much it. So what does it say? It looks complicated, but it's not. At many colleges, the full-time equivalent students, the number of full-time equivalent students, F, is n over 15, where n is the total number of credits for which students have enrolled in a given semester. They want us to determine the number of full-time equivalent students on campus in which students registered for a total of 29,265 credits. So remember, they said the number of credits is n, so they must be giving us n here. They're not saying F is the full-time number of students. They're saying this is the number of credits that they're taking, which they called n. So really all you have to do is replace n with that number, and that's it. So since it was n over 15, and this time my n is 29,265, holy moly, it's that number over 15. That's a terrible fraction, but if you think about it as division, it's a lot easier. That's really 15 divided into 29,265. Okay, 15 can't go into 2, but it can go into 29 once, with 14 left over. If I bring down the 2, see, what's 15 times, I don't know, 8. Ooh, that's getting pretty close, huh? Maybe I'll try 15 times 9 just to be safe. Ooh, that's close. Alright, it must be 9. 15 goes into 142, 9 times 15 is 135. If I subtract, I'm left with 7. If I bring down the 6, I know 15 times 4 is 60. 15 times 5, I think, is 75. Yeah, okay, good. There we go. 15 times 5 is 75. Now, last thing I bring down is a 5. 15 into 15, of course, is 1. Aha, so that must be it. 1,951. So there are blah, blah, blah full-time students. Alright. Good stuff. So that one looks scary just because it was a long word problem, but it was just them trying to get us to use a formula, basically. Not too bad. All right, now we're in the next section, 4.2, where it's all about percentage problems. Okay, so it kind of probably helps to remember a few things, if it's been a while, that percents you always want in decimal form. And if you remember, for example, 25%, 25 is a whole number, so it has an invisible decimal on the very right side. If you want to change it to its decimal form, you move its decimal to the left twice. So this guy translates to 0.25. So this is percent form, 25%. But once I moved the decimal twice, it became 0.25. That's the decimal form. And when you do these problems, every time you see a percent, you're going to want to automatically change it to a decimal to do your algebra. And then another thing is, remember, when you see the word is, we kind of talked about that before, but that's code word for equals. An equals sign. And then the word of, that's code word for multiplication. And what else? Oh, I guess if you see what, like in this example number 31, we see what. Think of that as a variable x. You know, because what is the thing you don't know, and of course the thing you don't know is what you want to, you know, call something. That's really it. That's all the trick to these problems, remembering what those code words are. And then you're reading this from left to right. Okay, it says 20, all right, got that. Is, remember, is code word for equals. 25%, remember we want to change that to a decimal form, that's 0.25. Of means multiply. What is the variable? X or n for number, whatever you want to use. So if you kind of remember these little clues, you can even write them on your little note card if you want, if that helps. Now we just have an equation to solve. So it's 20 equals 0.25. I don't know if I need the multiplication symbol. I know that when something's next to x, that means it's multiplying by x. Okay. Now I can solve for x by dividing by 0.25 on both sides. And that should be it. So x is 0.25 into 20. If I do that long division, remember, if you're dividing a decimal number into any other number, you can move the decimal to the right as many times as you want to make it a whole number, as long as you do the same to the other number. So this is a 20. I'm going to move its decimal to the right twice. So if I move the decimal of this guy twice, it'll be 25. If I move the decimal of 20 twice, it'll be 2 empty spots, but remember the empty spots you replace with zeros. Alright, now we're ready to divide. 25 can go into 200 8 times. 8 times 25 is 200. 25 goes into 0 times. Now there's nothing left to bring down, so it must be 80. There it is. I like percent problems because you can kind of check. Does that sound about right? 20 is 25% of 80. Do you think that's true? Yeah, sounds about right. 20, yeah, it's 25% of 80. Yeah, that sounds right. Okay. Now that we have the clues in our minds, it'll be easier. Let's see, number 32. What number is 2% of 840? Okay. So reading from left to right, let me think about my clues. What number, okay, we don't know what it is, so I'll call it x, is, okay, that means equals. Now 2%, be careful with 2% because 2% has a decimal to its right, so it's 2 point. If you move that decimal to the left twice, it moves the decimal once past the 2, but another time, so it's actually 0.02. Because remember, you're always moving the decimal twice to the left, always twice. Okay, we got that, and then the word of is multiply, 840. There, so this actually isn't even an equation I really have to solve. X is already isolated, just a matter of multiplying 0.02 times 840. So let's try that, 840, 0.02, alright. 2 times 0 is 2, 2 times 4 is 8, 2 times 8 is 16. Now remember how it goes when you try to place the decimal. You say, how many digits are beyond the decimal in these two numbers? Well, 840 has no digits beyond the decimal. It's all a whole number. The second number, though, has 2 digits beyond its decimal, a 0 and a 2. So there's a total of 2 digits. 0 plus 2 is 2. So my answer better have 2 digits beyond its decimal. I move the decimal to the left twice. So it must be 16.80. There we go. Or you could just write 16.8. Remember that any zeros at the end of a decimal number don't really mean anything. It just kind of looks cleaner to write 16.8, I think. All right, the last one of this row anyway. 66 is what percent of 550? All right, let's try that. Going from left to right, 66 is, that means equals, what, remember that's a variable. And I guess the percent part, I'm thinking, oh, that means x is going to be a percent. So just keep that in mind. What percent? Okay, x is a percent. The word of is multiply, and then 550 is pretty self-explanatory. So 66 is equal to x times 550, but usually you see 550, if you're multiplying x by something, that number is usually on the left, so that looks better. Alright, now I can solve for x by dividing both sides by its coefficient, 550. Alright, so that's not pretty. 550 into 66, ew. Oh well. Of course 550 is too big to go into 66, so I'm going to have to add a decimal and a 0 and then go ahead and divide. Thinking of that as a 660 now. 550 into 660, I'm pretty sure that only goes in once. 1 times 550 is 550. If I subtract those guys, I get 110. So I'm not getting a 0 remainder yet, but I imagine if I keep going, I will. And for sure on an exam, I would give you a problem that if you tried to divide a few times, you don't have to go through the cycle forever. It would eventually end up with a 0 remainder. So now I have to bring another 0 down and ask myself, 550 into 1,100, I think it actually goes in exactly twice. 2 times 550 is 1,100. That's perfect. So x is 0.12, but remember it says what percent. So x, they're giving us x is 0.12, but this is the decimal form. So remember earlier in a previous problem we said, like if you're starting with 25%, to change it to decimal form, you move the decimal to the left twice. But now we're going backwards. We have the decimal form. That means someone moved the decimal to the left twice. We need to do the opposite and move it to the right twice. So it becomes 12%. To the right twice, yeah. Just depends which way you're going. If you're starting with the decimal and you want to move to a percent, you need to move the decimal to the right twice. But if you're going backwards from a percent to a decimal, you move it to the left twice. Yeah, it just kind of depends which direction you're trying to go. Alright, these last few problems here in this section, they're kind of like the ones we just did, except they're giving us context. So what I like to do is read the problem, like this is kind of a complicated problem, and then try to phrase it in a very simple way. I try to phrase number 34, 35, and 36 like number 31, 32, and 33. So let's see, number 34 says, a local Little League has 60 players, of whom 20% are left-handed. How many left-handed players are there? So it kind of sounds like, okay, 60 players, that's the total number of players, and 20% of those players are left-handed. So I think what we're looking for is, really the question is, what is 20% of 60? I think, right? Because they're saying 20% of those 60 players are left-handed. There we go. So I think that's really, it's invaluable to be able to rewrite those guys. Just try to phrase it in a very simple way like number 31, 32, 33 were. And then you can solve it just like we did in the previous problems. From left to right, what is a variable x? Is equals 20%. Remember, you want that in decimal form. If I move his decimal to the left twice, it becomes 0.2 or 0.20. Of is multiply, and then the number 60. So all it really comes down to is what's 60 times 0.20? 0.2. And of course 0.20 is the same as 0.2. See, 2 times 0 is 0, 2 times 6 is 12. There's only one digit beyond the decimal, so I only need one digit beyond the decimal here. It must be 12.0 or just 12. So that must be, I guess, since this is a word problem, they probably want their answer in a sentence. there are 12 left-handed players. There we go, that's probably good. And on a midterm, I would try to prompt you. You know, if I wanted a full answer, like a full sentence, I'm going to say that on there. So I didn't write that on here, but I should. It's just, like it would say something like, write your answer as a complete sentence or something. That way you won't forget. I don't want you to worry too much about that. As long as you read the directions, you should be fine. Alright, let's try number 35. Try to read it and then see, like, what's a simpler way to say it, like we did in the last one. Jerry left a $4.68 tip on a meal that cost $36. I think that's what it is if I erase this guy. Yeah, okay. What percent of the meal's cost was the tip? So I guess, you know, the meal's cost, that was the $36. And then the tip was $4.68. So I think what they're saying is, what percent of the meal's cost was $36 is the tip, which was $4.68. That's really what they're asking. What percent of 36 is 4.68? And now if I translate that into an equation, what'll that guy be? What is x? Percent, remember if it says what percent, just keeping in mind all my answer is going to be a percent. And the word of means multiply. $36, I don't really need the dollar sign. I mean, doing the math now is not going to help to have a dollar sign. Is means equals. And then 4.68. Again, I'm dropping the dollar sign because it's not going to help. On the left, you have x times 36, but we're more used to that as 36x. The number on the left, the variable on the right. Now, if I want to solve this for x, I just divide both sides by 36, and that should do it. Alright, now I'm doing long division. 36 into 4.68. Okay. So I think to me, since the divisor, 36, it doesn't have a decimal, I don't really feel like I need to move the decimals over at all. I'm okay. I just need to make sure that my answer has a decimal in the same place as my dividend. I'm going to place the decimal right above it. And now 36 can't go into 4, but it can go into 46 one time. 1 times 36 is 36. If I subtract, I'm left with 10. If I move the 8 down, now I'm dividing 36 into 108. That's maybe 3. Let's try that. Yeah, okay, good. 36 times 3 is exactly 108. Perfect. Alright, so that must mean x is 0.13. But remember, whenever you're looking for a decimal, once you solve it, that's going to be the decimal form of that percent. Or sorry, whenever you're looking for a percent, you're going to be left with the decimal form of that percent. Excuse me, so I need to move the decimal to the left twice. Or sorry, to the right twice. 1, 2, that'll make it 13%. Okay. So I should say it in words. Jerry left a 13% tip. There we go. On that one again, I would prompt you and say, remember to write your answer in sentence form. Now we can try the last one in this section. So what is this one talking about? It says, it has been determined that by the age of 10, a girl has reached 84.4% of her final adult height. That's kind of interesting, huh? 10's pretty young. But it is true that girls grow fast and stop, and then boys start growing more. So wow, that's pretty early though, 10. Anyway, Dana is 4 feet 8 inches, which is 56 inches, tall, not tall, what the heck, at the age of 10. Predict her final adult height, rounding to the nearest tenth of an inch. Okay. So one thing I have to note, or kind of determine on my own is it going to be more useful to think of Dana's height in this form, 4 feet 8 inches, or is it going to be more useful mathematically to think of it as 56 inches? I think in math, whenever you're dealing with mixed units, like 4 feet 8, no, what is it, 4 feet 8 inches? That's not useful at all. You should have it all in terms of one unit, you know? 4 feet, that's one unit. 8 inches, that's another unit. If you just write it as 56 inches, that's going to be a lot easier. Yeah, so just instead of thinking of her as 4 foot 8, think of her as 56 inches tall. That'll be a lot easier. Alright, so right now she's 56 inches tall. That's 84.4% of her final adult height. So I guess what we're asking is what... Oh no, how about 56 is what... No. Is 84.4%. We know the percent. Excuse me. 84 is... 84.4% of what? Because we know the part of it. 84.4% of her adult height, which we don't know, is 56. That means 56 must be 84.4% of some adult height that we don't know yet. Okay. So reading this from left to right, I'll translate into an equation. 56 is, that's equals. Remember, 84.4%, we want that in decimal form. If I move the decimal to the left twice, it becomes 0.844. Of is multiply, what is the variable? So it's 56 equals 0.844x. Now if I solve this guy for x, I'll divide both sides by the 0.844. And that should be x. Alright, let me try to do long division here. I would be dividing 0.844 into 56, but we know by now that when the divisor has a decimal in it, it's kind of hard to do long division. So I'm going to move that decimal to the left, or sorry, to the right. I guess 3 times would make it a whole number. But if I do that, I better do it to the other number too. 1, 2, 3. So now it'll become 844 with no decimal. 56, but if I move the decimal 3 times to the right, it'll add 3 extra zeros. And now I'll try to do my division. Okay. 844 can't go into 5, it can't go into 56. It can't go into 560, but it can go into 5,600. How many times? I don't know. Maybe I'll try 5? I don't know. I'm just guessing. What's that? I think that's a little small. Let's try one more. 844 times 6. I think that's pretty close. I think that's it. 6 times 844 is 5,064. If I subtract those guys, what am I left with here? I'll be left with 536. Whoops. If I bring down the 0, does 844 go evenly into that? Probably not. So let's try... I guess we know that 844 times 6 is 5,064. I think 844 times 7 would be really too big, so I think it's another 6. 6 times 844 is, we already know, 5,064. If I subtract those guys, I've got, 296. Alright, I don't have a 0 remainder yet, so I better put a decimal and a 0 and bring down a 1. Or sorry, bring down a 0. Now, 844 into 2,960? I can't see that going in very many times. How about 3 times? Maybe, no, I think that's it, huh? Dang. Alright, I think it just goes in 3 times. 3 times 844. 844, yeah, like we saw down here, was 2,532. See if I subtract those guys, I'm left with 428. Ugh. Bring down another 0, and now my patience is kind of, not so great, huh? Oh my gosh, you guys, I forgot that this problem, you notice it says, predict her final adult height, rounding to the nearest tenth of an inch. So I'm almost done. I only need one more digit, because if I have one more digit, that'll help me round to know, okay, is this 3 going to stay a 3, because that's the 10th place, or is a 3 going to be rounded up to a 4? Alright, we just need one more digit. I was thinking, what the heck? Alright, 844 last time into 4,280. Well, notice 844 times 5 was pretty close. 4,220, so I think that's the one. 5. And then you know what? I could subtract, but it's at this point, who cares? Because now I know what the answer is. 66.35, but that 5 is large enough to round the 3 up to a 4. So it'd be 66.4 inches. So okay, what's her name, this chick, this girl? Dana. Dana will be 66.4 inches tall. And if you want to know how tall is that in like blah feet and blah inches, well, how many inches are in a foot? There's 12 inches in a foot. So you have to think, how many feet can I get out of these 66.4 inches? 12 into 66, it goes in 5 times. Because 5 times 12 is 60. Now 5 times 12 is 60. There's 6.4 inches left over after that. That's pretty tall, right? For a girl, I think that's definitely taller than average. 5 feet, 6.4 inches, yeah. Dana, she must have drank a lot of milk, right? Something. Is that the trick? I don't know. Who knows? I think genetics probably has a lot to do with it, right? I'm no expert. But I'm pretty sure if you see tall parents, you usually see a tall kid. Anyway, don't get sidetracked, right? I see what you're saying. All right, section 2.5. Having a good time? Oh, man, this is taking forever. I'm sorry. But keep in mind you can skip through all this stuff if you don't really care about some problems. All right. Number 37. This one helps me to draw a picture. Okay, the perimeter of a rectangle. All right, I can draw a rectangle. The perimeter is 36 centimeters. Okay. And if you remember, the perimeter of a rectangle, it's 2 length plus 2 width. So that must be 36. Because remember, perimeter means all the way around, so it's like 1 of the lengths plus 1 of the widths plus a second length, that makes 2 lengths, plus a second width, that makes 2 widths. Okay. But they're saying that the length is 4 centimeters greater than the width. So let's say this is the length, for example, and this is the width. The length is 4 centimeters greater, so I guess something plus 4, than the width, and the width is W. So I think that'll allow us to solve this equation. If I replace the L with W plus 4 here, because as it is right now, 2L plus 2W equals 36. I can't solve that. You can only solve an equation when there's one variable. But if I replace the L with W plus 4, then the only variable left is W. And I will be able to solve it. Oops, equals 36. Alright, so I think for me, drawing the picture helps a lot and labeling the sides and all that. But if you feel like you don't have to do that, then don't worry about it. You don't have to. Okay, what is this? Anyway, alright, let me distribute the 2. That'll be 2W plus 8 plus 2W equals 36. Alright, there are a couple like terms on the left. 2W and 2W make 4W plus the 8 that was there equals 36. Now I can solve for W first by subtracting 8 from both sides. So I'll have 4W equals 28. And I'll be done if I just divide both sides by 4. That'll give me the width. 7, okay. And I guess they were talking about centimeters, so that must be the unit that we're talking about. The width is 7 centimeters. But they want to know, find the width and the length. If I found the width, how can I find the length? Well, remember we had this relationship over here between length and width. Length is width plus 4. Because we said the length is 4 more than the width. So if I know the width, I can put that there. Length is width, which is 7 plus 4. So length must be 11 centimeters. Okay. So we got them. You can say that in a sentence, of course. That's probably what they would prompt you to do if this were on an exam. Yeah, the width of the rectangle is 7 centimeters, and the length is 11 centimeters. Something like that. You can phrase it however you want. Alright, these next ones are everybody's favorites, I guess. The distance, rate, time problems. Ugh. And just because I know these are so difficult, I'm definitely going to prompt you on a midterm or final or whatever. I'm going to give you this diagram so you remember that, oh, I have to use that diagram. Because even then it's hard enough to remember how to fill it in and all that stuff. It's okay, just to reiterate, if you remember these problems, what you do first is either distance, rate, or time. They should give you just outright. You know, they'll tell you the distances, they'll tell you the rates, or they'll tell you the times. That's what we want to fill in first. And then also there should be two parts of this trip. So I'm going to read through the problem and see kind of what are the two parts of the trip they're talking about. So it says Theodora, she drove, excuse me, on the Blue Ridge Parkway. So maybe I'll label one as the Parkway at 40 miles per hour. Okay, so her rate, remember rate means speed, same thing. It was 40 miles an hour on the Parkway. And then she drove on the interstate, or highway, whatever you want to call it, at 70 miles an hour. So that was her speed there. So just like we said, they gave us those outright. Either the distances they'll give you, or the rates they'll give you, or the times. Okay, and then from there, they should give you some kind of relationship between the remaining things, like one distance was 5 more than the other, or the times maybe. The time for one took 5 less than the other, or something. They'll give you some relationship so you can call one x and call the other one x plus 5 or whatever. So I think the second sentence gives it to us. She drove 3 times as long, so that must be time, right? On the Blue Ridge Parkway as she did on the interstate. Okay, so I guess if you call the time she took on the interstate x, she drove 3 times as long on the Blue Ridge Parkway, right? So that means however long it took her on the interstate x, multiply that by 3 because it took her 3 times as long. Alright, that sounds good. And the very last part of this table you'll fill out using the formula. Remember, the formula is distance equals rate times time. And so if you focus on one row here, for her, when she drove on the Parkway, her distance is her rate, which is 40, times her time, which is 3x. Just getting them from the next rows, or next columns. So you could write 120x if you want. I could do that in the next step or right now. And then the same for the interstate. On the interstate, her distance, which is the blank spot, is her speed, which was 30, or her rate, times her time, which was x. So that's probably the hardest part to remember. The part that people usually forget or get stuck on is if there's one column left to fill out, you're going to have to use the formula to fill it out. Okay. So now that we've filled it out, we're pretty good. Now the problem should give you, maybe in the end of the problem, some spoken or unspoken relationship between those things you just filled out. So probably going to give us some kind of relationship between the distances. So the last sentence here, she drove a total of 285 miles. So that's distance, right? So it's like, I can brainstorm if I want to. If you kind of need some brainstorming. Her distance on the Parkway, oops, plus her distance on the interstate was 285 miles, because they said that's how the total amount she drove, and she drove on 2 places, the Parkway and the interstate. But her distance on the Parkway, we filled that out, it's 40 times 3x. And her distance on the interstate, we filled that out too, it was 70 times x. So there's our equation, and now I might as well multiply. 40 times 3x, that's 120x. 70 times x, you can just write 70x. And now this is where it gets easy, you're just solving now. 120x and 70x, those are like terms, I can write 190x. And then the last step to solve for x would be divide both sides by 190. So x must be 190 into 285. Alright, I know it doesn't go in evenly, but maybe it's some nice decimal number. Well, 190 can only go into 285 once at most, I know that. But what's left over there? 95, I think? Alright, so it's not going in evenly. Let me bring down another 0. Now it's 190 and a 950. I just gotta guess. How about... I don't know, 4? Not enough. Let me try one more. 190 times 5. 5. Ooh, that's perfect. 190 times 5. 5 times 190 is 950. Perfect. So it must be the answer is 1.5. And what was x again? X was what we filled in here. So that must be 1.5, and that was her time, because it was under the time column, but it's across from the interstate. So she must have driven for 1.5 hours on the interstate. Is that what they wanted? Yeah, how long did she drive on the interstate? Okay, so that's it. I'm just going to write, kind of fill it, or sum it up in a complete sentence. This is the one where her name was Theodora, right? Yeah, okay. Theodora drove for 1.5 hours on the interstate. And yeah, don't feel bad in the end if you find X and you say, wait, what was X again? Just look back at your table and say, all right, this was where X was. It was under time, so it must be time. And it was across from interstate, so it must be the time, her time on the interstate, which is exactly what they asked for. All right, now the number 39 is a similar problem. I only put it in there because I feel like these problems are kind of difficult. So the more practice, the better, probably. Okay, let's try number 39. Similar. It's okay. I'm gonna just, usually what I do, the first thing is kind of read the problem, make sure it makes sense, and then kind of label the two parts of the trip. What are they called? So Shannon drove for 3 hours on a highway, and then 1 hour on a side road. Okay, so it looks like first she's driving on a highway, and then a side road. Okay. Her speed on the highway was 20 miles an hour faster than her speed on the side road. If she traveled a total of 220 miles, how fast did she travel on the side road? Okay, sounds good. The first thing I'm going to look for is, what do they just give us right off the bat? Do they give us the distances? Do they give us the rates? Or do they give us the times? So Shannon drove for 3 hours on a highway. All right, that's time, right? 3 hours. So I'm going to lay that over in the time area for highway. Excuse me. And then 1 hour on the side road. That's time on the side road. All right, the next thing they should give me is some relationship between, the distances or the times. And they say her speed on the highway was 20 miles an hour faster than her speed on the side road. Okay, so if I say X is her speed on the side road, then 20 miles an hour faster on the highway means you're adding 20. Yeah, going faster is more, right? More speed. Okay. And just like in the last problem, the last thing we fill in is the very last column. You're going to use the formula to fill it in. It's rate times time. So for the highway, her distance is going to be her rate, which was X plus 20, times her time, which was 3. So yeah, for distance, you're just saying it's equal to this thing times this thing. So here, this guy's equal to this thing times this thing. And the same thing on the side road. Her distance is equal to her rate, which was X, times her time, which was 1. Here, equal to that times that. Okay. So we got everything filled in. Now we should look for some relationship between the distances that they give us. If she traveled a total of 220 miles, okay. That sounds like the last one where, I guess her distance on the highway, which was this, plus her distance on the side road, which was this, should be a total of 220 miles. Because that was her total for both highway and side road. Distance on highway. This is her distance on the side road. And then the total distance they gave us. Whew. I always feel really good at this point. Like, oh man, all the hard part's over. Now I'm ready to solve the equation, which isn't, sadly, that's the easy part. Isn't that sad? I thought in algebra the hard part would be solving problems. But let me distribute that 3. That'll become 3x plus 60. And then plus 1 times x is just x. The like terms on the left make 4x plus 60. And I'll isolate x now by moving the 60 over, subtract that guy. I think it'd be 160 over there on that right side. Now I can solve for x by dividing both sides by 4. And that should do it. Let's see. So 4 goes into 160 40 times. And x at the end, I always forget what x stood for. X was, where's my table here? Aha, here is x. He's in the column for time, rate, so speed on the side road. Okay, so that must be speed on the side road. Is that what they asked for? Yeah, how fast did she travel on the side road? Good, okay. What's her name? Shannon. Shannon drove 40 miles an hour on the side road. Whew. All right, we did it. That's such a nice answer too, so I almost feel like we have to have gotten it right. You know, if we got it wrong, what are the chances? Come on. Whew. Okay. Now move on to the next section. I think things are getting better. That was pretty difficult. If you remember 2.6, that was the section about inequalities, which, like, for example, if you focus on number 40, that's coming up here. Where's that guy? N minus 4 or greater than negative 3. Remember, you can solve these as if this inequality was an equal sign, you know, so you can pretend it's n minus 4 equals negative 3. You know, how would you solve that for n? Except if you were to ever multiply or divide by a negative, you got to flip the inequality. So don't forget that part. Alright, so anyway, we'll just solve it and then go about our business. If that were an equal sign instead of a greater than, I would move the 4 over to solve for n, right? And n would be greater than 1. But notice I never multiplied or divided by a negative number. So it's a lot of times you don't have to flip. It's only if as you were solving, you multiplied both sides by a negative number or you divided both sides by a negative number. Then you have to flip. That doesn't always happen, so don't feel like you always have to flip it. Alright, now we got n is greater than 1. So they want us to solve it, which we did. That's the solution. But then they want us to graph it, so I'm going to draw a little number line. And remember, you don't have to make it a pretty number line. The only number I really care about is that number that you just had right there, 1. So n greater than 1. And then just say, okay, where are all the numbers greater than 1? Since n is greater than 1, where would he be? Somewhere off to the right. On the number line, right, all the numbers to the right are larger, and the numbers to the left are smaller. And then remember, you want to see either a bracket or parentheses on that number. But since this inequality does not have an or equal to, it's just a strict greater than, it's going to be a parentheses. So remember, yeah, if it's a strict greater than or less than, you're going to have parentheses. But if you have a greater than or equal to, or less than or equal to, if there's some kind of or equal to, that's when you have brackets. That's kind of the key to remember there. So we've graphed it, that's perfect. And then we're going to place our solution in interval notation. So if you remember interval notation, it kind of has a number, or infinity, comma, another number, or infinity. And it's all about, when you look at your graph, how far to the left does the graph go? How far left? And then the right number is how far right. So if I look at my graph, I don't see any green, the color that I was using past 1. So that's as far to the left as it goes. And how far to the right does it go? Well, the arrow indicates it's going on forever, so it actually goes to infinity. And if you remember, infinity always has parentheses next to it no matter what. You'll never see a bracket on infinity. It doesn't make any sense. On the number, though, it might be bracket, it might be parentheses. It all depends on what was on the number and the graph. But since the graph had parentheses, I'm going to keep parentheses. But if the graph had a bracket, then I would use a bracket on the 1, but not the infinity. So keep that in mind. Yeah, it's either going to see parentheses and bracket or both parentheses. Okay, whew. There's kind of a lot to remember for these problems. Let's try number 41. Okay, I see a variable on either side, so I'm trying to treat this guy like an equal sign. I'm going to try to get the y's together. And remember we said you want to get the smaller coefficient on the side with the larger. And these are actually the problems why I say that. It's because if you get the smaller coefficient on the side with the larger, you won't have to divide by a negative. And you'll avoid having to flip the inequality or having to remember to flip the inequality. But if you kind of move things on whatever side you want, you might be having to divide by a negative. And then you might forget to divide by a negative, which would be bad. So I'm going to look at these coefficients here. We got -8 and -7. Actually, -8 is smaller because it's further to the left on the number line. So I'm going to make him move over to the right side with his friend over here. And I'll be left with a 12 on the left side. I don't need to flip the inequality because I didn't do anything. I didn't multiply or divide by a negative. These guys combine to just make y, or 1y. That was good. And if I had moved the 7y to the left, I'd have a negative y. And that would have actually given me an extra step. I'd have to not only isolate y, but then get rid of the negative. It's a lot more work. All right, now if I want to solve for y, I'm going to move that 12 over. Subtract 12. Oh, and then look at that. 0 on the other side. Ew. And I didn't, even though it's a negative, I didn't multiply or divide by a negative. Remember, if you subtract, that doesn't make you flip the inequality. It's only when you multiply or divide by a negative. Whenever you have an inequality, you don't want to see your variable on the right side, so I'm going to switch the two. The y on the left, the 0 on the right. But when I do that, I have to flip the inequality backwards. It's almost like if you want the variable on the left, yeah, first of all, the variable should be on the left in the solution. If you want to do that and you flip them, you've got to think of the mirror image. Kind of, because you're switching what's on the right and what's on the left, so your inequality should also be the mirror image, the kind of backwards part of it. So y greater than or equal to 0. All right, we've got the solution. Now they want us to graph it. So 0's here. Let's see, where's all the stuff that's greater than 0? All the numbers to the right of 0 are greater, not to the left. But since this time there's an inequality that has an or equal to, it's greater than or equal to, I'm going to have a bracket facing the direction of my arrow. Whereas in the last one we had parentheses because it was just a strict greater than. So it's not about which way the inequality is facing. It's not because it's greater than versus less than. It's, is there an or equal to or not? Is there a little line below the inequality like that? Alright, anyway, there it is. So then the last thing is interval notation. I asked myself, how far to the left does this graph go? Well, it starts at 0, comma, how far to the right does the graph go? It goes off to infinity. And we know on infinity it's always parentheses, but on 0, or the number, whatever number it is, you just copy what was on the graph. Since I saw a bracket on the graph, I'll see a bracket in my answer. There it is, okay. So how about number 42 now? This one looks kind of complicated, but remember, you're just solving for your variable. Since t is here, I'm going to move everything over one at a time, probably subtract the 5 first. And again, even though I'm doing something with a negative, sort of, I'm subtracting, I'm not going to flip the inequality because I only flip it when I multiply or divide by a negative, not when I add or subtract. Now if I want to isolate t, I could get rid of the 7 and the negative in separate steps, or you can get rid of them in the same step. But I think it's probably more natural to get rid of them in separate steps. That's probably what people would think of first. Since 7 is being divided by t, I'll do the opposite and multiply by 7. And that way that'll cancel the 7 on the bottom. On the left side, negative 2 times 7 is negative 14. On the right side, the 7's cancel, but I'm still left with a negative. And I didn't multiply or divide by a negative number, right? I just multiplied by a positive 7. So I don't flip the inequality. But now I have to get rid of that negative, so I do have to multiply or divide by negative 1. And now since I'm multiplying or dividing by a negative number, I do have to flip the inequality backwards. Now instead of a less than, it'll be a greater than. So I think this was the first time we've had to flip the inequality, huh? But you know what you could have done at this stage right here is instead of multiplying by positive 7, you could have multiplied by negative 7, and that would have knocked out the 7 on the bottom and the negative on the side. And you would have skipped that step and just gone straight to here. That would have been kind of nice if you thought of it, but if you didn't think of it, don't worry, not a big deal. But remember on these you want your variable on the left, so I'm going to switch the t and the 14, but that means that I better flip the inequality backwards. Because remember, it's the mirror image when you flip the two. There it is, okay, t less than 14, alright, number line. And don't worry about putting a bunch of numbers on the number line. I'm just going to put 14, sure, he's right here. Doesn't matter, you can put it right in the middle or wherever you want. But I want all the numbers that are less than 14. Where are all the numbers that are less than 14? They're off to the left on the number line, like 13, 12, 11, 10, 9, etc. But since the inequality is just a strict less than, there's no or equal to, I have a parenthesis on 14, not a bracket. So that looks like a good graph. Now the last step is the interval notation. I look at this graph and I say, how far to the left does it go? Well, actually it goes on forever, so it goes off to infinity. But remember, when it goes off to infinity to the left, you put a negative. on infinity. And it's always a parentheses on infinity. Comma. There's always a comma in the middle. How far to the right does the graph go? It stops at 14. And there's a parentheses on 14, so I'll copy what was on the graph. There we go. So remember, it's kind of like between these two. Your answer is always going to have infinity in it, either on the left or on the right. If it's on the right, it'll be positive. If it's on the left, it'll be negative. Your answer will always have a parentheses next to infinity, but it could have a bracket next to the other number, or it could have a parentheses next to the other number. It all depends on what kind of inequality you had. Alright, let's try the last one here. Ooh. Number 43 has decimals. So you know we could play the same trick as we did in previous problems. If I don't like decimals, I can multiply the entire thing by 10. Or 100, I guess if you want to move the decimal to the right twice. Like if there's one or more of these numbers have 2 digits beyond the decimal, then you want to multiply by 100. God forbid if there were 3 digits beyond the decimal, you multiply by 1,000, etc., etc. So okay, let me see. I'm going to multiply everything by 10, every single term here, on both sides of the equation. And it's going to make some of the numbers fairly large, but at least it'll make it so I don't have any more decimal numbers. I don't like that. So let's see, 10 times 0.7, that'll move the decimal to make it 7x. 10 times negative 15 will make it negative 150. 10 times x will be 10x. And I don't flip the inequality because I'm multiplying by a positive number. I'm multiplying by 10. It's only if I multiplied by a negative number, I'd have to flip it. 2x times 10 is 20x. Negative 8 times 10 is negative 80. And lastly, negative 0.4x times 10 is negative 4x because it moves the decimal to the right once. This looks a lot nicer, I think. Even though the numbers are a little bigger, I'd much rather deal with big numbers with no decimals. That's personal. So doing this step, multiplying by 10, is totally optional. You don't have to do it. But now my like terms are 7x and 10x. That's 17x altogether, minus the 150 that was hanging out there. And the other side of the inequality, I have 20x and 4x. Sorry, 20x minus 4x makes 16x. And then minus the 80. Whew. Alright, I'm going to move the smaller x to the side with the larger x. I think 16x is smaller than 17x, right? So I'll subtract the 16x over to the left. Then there's just the x left, or 1x, but 1x is the same as x. Minus 150. I subtracted, I didn't multiply or divide by a negative, so I'm not going to flip the inequality. And now I want to isolate x. The last thing I need to do is just add the 150 over. Alright, so I think we're done, and we never had to multiply or divide by a negative, so I never had to flip the inequality. X less than or equal to, that'd be 70, negative 80 plus 150. And such a large number, this is where I'm glad I don't have to draw all the numbers on the number line. Can you imagine if you had to start at 0, 1, 2, 3, all the way to 70? No thank you. I'm just going to put a 70 wherever, somewhere off to the right, I guess, whatever. Alright, I want all the numbers that are less than or equal to 70. The numbers that are less than 70 or equal to are to the left. The arrow should go to the left, but I have an or equal to in my inequality, so there'll be a bracket on 70. And then as far as interval notation goes, I look at the graph and I say, how far to the left does it go? It goes to infinity, but of course on the left, infinity should be negative infinity. And there's always parentheses on infinity, comma. The number on the right, it goes as far as 70, and there's a bracket on 70. Whew, so there it is. Alright. Oh man. We're getting there. Alright, so these last couple problems in this section are they're getting us to set up our own inequality and then have to try to solve it. But it's still going to be a similar thing. Although in these problems, notice they didn't say anything about, you don't have to graph your inequality or you don't have to put it in interval notation. Since this is a real world example, we just kind of say the answer in a sentence. So it says the length of a rectangular frame is 53 centimeters. Alright, since they're talking about a shape, I always like to draw a picture. It helps me visualize better. So it doesn't really matter which one you call which. Maybe I'll call this the length and this is the width. So it says the length is 53 centimeters. Okay, so we know the length, we don't know the width. For what widths, okay, so I guess we're trying to find the width. Width is question mark. For what widths would the perimeter be greater than 160? Okay, so I guess what we want is the perimeter to be greater than 160. So it's good to at first kind of like brainstorm, take their words and try to get closer to math with it. Greater than, I know that symbol. 160 is just a number. Alright, so I think the perimeter is what I need to work on, because that doesn't look very math-like. But I do know the formula for perimeter. Remember, a couple problems back we said perimeter is twice the length plus twice the width. So we want 2L plus 2W to be greater than 160. And you know what? We know L, right? They told us the length is 53. So we should just be able to replace L with 53. It'll be 2 times 53 plus 2W is greater than 160. Yeah, it's not like they said the length is 53 more than the width or anything fancy like that. They just said the length is 53. So we should just be able to replace it. So it's 2 times 53, that's 106. Plus 2W is greater than 160. And now this is an inequality I can actually solve since there's only one variable left. I'll start off by moving the 106 over, subtract it. I subtract those, I'll get 54. So 2W is all by himself, greater than 54, right? Okay, almost done. If I want to isolate W altogether, I'll have to divide by 2. And notice we've never divided or multiplied by a negative number, so there's no need to flip the inequality. W greater than, that'd be 27. And since this is a word problem, they're kind of talking about a real life thing and there's a lot of words in it, I probably should summarize this in a sentence. Because what they ask, for what widths would the perimeter be greater than 160? Okay, so I'm going to say the perimeter would be greater than 160 for widths, I guess, how do I read this out loud, this inequality, greater than 27, and I guess the units they're using in the problem are centimeters, so I probably should add those units. So the perimeter would be greater than 160 centimeters for widths greater than 27 centimeters. Sounds good. Alright, good. Alright, how about 45? To make copies of blueprints, Vantage Reprographics charges a $6 setup fee plus $4 per copy. Myra can spend no more than $65 for the copying. What number of copies will allow her to stay within her budget? Okay, so I think what they're trying to say is, it's like, just to brainstorm, the amount Myra will spend, I'll have to think about what that is, has to be less than $65? How about, do you think so? No more than. So she doesn't want to pay more than that, but you know what, it might sound like 65 is okay, so I think I can say not only less than, but less than or equal to. Because they said no more than. That kind of makes it sound like she's okay with spending 65 but not more. Alright, that's good, that's good. And then, okay, another thing too that might help with this one is search through the problem and see what are they asking us to find, and that'll give you a clue as to what you should make your variable be equal to. So they said in the end, what number of copies will allow her to stay within her budget? So that's a clue. Maybe that means we should let x or whatever variable be the number of copies she'll make. Okay. So how much will she spend? Let's see. How do they set up their prices again? Notice, okay, it says they charge a $6 setup fee. So it sounds like no matter how many copies she makes, she's going to be paying $6. So she's paying those $6 plus something for her copies. So it's $4, holy crap, $4 per copy. Oh, blueprints, okay. I was thinking she should just go to Kinko's. I'm pretty sure it's less than $4 a copy. But maybe blueprints are more expensive, okay. So I guess if it's $4 per copy and she makes X copies, then it should be 4 times X would be how much she's spending on those copies, right? Like let's say, it's not X copies, let's say she made 5 copies. Well, how much would she spend? It would be, well, it's $4 per copy, and she made 5 copies, 4 times 5, you know? But since we don't know the number of copies, it's just 4 times however many copies she made. So this must be the inequality we're trying to solve here. Alright, I'm going to solve this guy. Move the 6 over. Then 4x is all by himself. Less than or equal to, that'd be 59, right? Yeah. And then the last step would be to divide by 4. And I haven't had to divide or multiply by a negative, so there's no need to flip the inequality here. X less than or equal to, that's not pretty. 59/4. So we could make that a decimal because this is a real life situation. Or you can make it a mixed number if you like that. I kind of like that. 4 can go into 59 how many times? Let's see. Okay, this means this is the same thing as 14 is the whole number. The remainder is 3. And the divisor was 4. So she'd have to make less than or equal to 14 3/4 copies. For this problem, though, if you think about it, how can you make 3/4 of a copy of a blueprint? I think when you make copies, you can either make a copy or not. So I think I would say probably Myra has to make less than 14 copies. Less than or equal to. Make 14 or fewer copies to stay within her budget. Yeah, I guess you could have probably said less than 14 3/4 copies, but kind of using logic, I don't think there's any way to make 3/4 of a copy. It's kind of like, you know, how people say the average family has, what do they say, two and a half kids? You know, you're like, wait, what the heck is half a kid? How does that even happen? There's not really half a kid running around, so you'd probably say, oh, most families have 2 or 3 kids, somewhere in the middle. That's kind of why this doesn't really make sense. How can you have 3/4 of a copy? Anyway, that was pretty tough. Actually, the next section is a lot easier, so it's kind of a nice break. You probably can fast forward through this as a matter of fact, because you're probably bored and you've already seen all this before. But okay, we're in section 3.1 now, and they just kind of want us to be able to look at a graph, you know, a bar graph, and just kind of get information off of it. So it looks like this bar graph, it says it surveyed 50 people and determined their favorite dog breeds. So it looks like you can kind of tell the highest bar would be the most popular breed, and the lowest bar would be the least popular, blah, 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 blah. You know. And then on the left, it kind of tells you exactly how many people voted for that dog. So if you kind of, I don't know, narrowed in on one dog, say the collie, for example, how tall is that bar? Well, it lines up right here with 6. Okay, so there must have been 6 people voting for collie. You know, that kind of thing. That's how I would read this bar graph. The first problem, number 46, it says, how many people cited the Chihuahua as their favorite dog breed? So I'll just look at these bars and say, all right, which one of these is a Chihuahua? There he is, almost on the very right side. So I look at the height of the bar for the Chihuahua and try to line it up with the numbers over there. Where's that line up? At 8, right? Yeah. All right, so there must have been 8 people. Yeah, sounds good. Okay. Number 47 says, 8 or more people voted for which dog breeds? Okay, well, I can kind of cheat and say Chihuahua. I just found that out. I love it when I do work and it you know, helps me twice. Okay. So pretty much what you're looking for is, how many of these bar graphs, or how many of these bars are at least as tall as that red line I just drew, you know, because that was 8 people. Anything below that is less than 8 people. Anything above that is more than 8 people. So I guess other than the Chihuahua, what other bar is higher than that? This bar. And what does he correspond to? The Golden Retriever, everybody's favorite. Come on. Why are they so popular? I guess they're real sweet. And they're real cute. I don't know. They are. Come on. Okay. Any more bars that are taller than that line? Yep, the guy on the very left. What is that guy? Cocker Spaniel. I can't really picture that dog. Is that the one kind of curly hair? I don't know. Anyway, sorry. You're like, quit getting off topic. Shut up. I think Cocker Spaniel's the last one there. Every other breed is below that bar. Spaniel. All right. Nice. Next problem. Exactly 4 people voted for which dog breeds? Okay. This is probably, now they're not talking about a certain dog. They're talking about a certain number of people. 4 people. So I'm going to look at the left side and say, all right, where's 4 people? Here they are. And then try to line up the 4 with, are there any bars that are exactly as tall as that 4? See, so far they're all taller. So far they're all tall. Oh, this guy right here, right? He's exactly as tall as the bar. That's the one. Doberman. Doberman are pretty awesome looking. Come on. Come on. It's hard not to be, I don't know. It's hard not to be sort of intimidated, but also like respectful, you know? Dang, that dog is awesome. I don't know. But that's, yeah, the other bars are either lower than that or higher than that, right? Like German Shepherd was close, but I think German Shepherd's between 4 and 6. It's like at 5, you know, 5 people. But Doberman's exactly on the 4. All right, last problem talking about doggies. What is the most popular dog breed? Well, that'd be the one that most people voted for, which is the tallest bar here. That's the middle guy, Golden Retriever. Everybody's favorite. And notice they didn't say how many people voted for him, so I don't need a number. I just need to say Golden Retriever. Retriever. There we go. Beautiful. All right, that wasn't so bad. All right, I think this is, like I said, these problems here are a nice break from the previous section where they were pretty tough. This one says they want us to plot and label the following points. Okay, I think I can handle that. The first guy, the first point A is, but when they say label, I think they just mean when you plot a point, put A next to it. When you plot B, put B next to it. So we know which one's which. So 2, 6. I'll have to go over to 2 on the x-axis. There it is. Because remember, the left number is x and the right number is y. And the x-axis is the horizontal axis, and the y-axis is the vertical axis. I'm trying to line up 2 on the x-axis with 6 on the y-axis. There it is. So this is the point that kind of is above 2 on the x-axis, but to the right, or to the left, whatever, of y on the y-axis. Or 6, sorry, 6 on the y-axis. So don't get those mixed up. If you did x, you know, you thought, oh, 2 on the y-axis and 6 on the x-axis, that would give you the wrong point. So it really matters x versus y or y versus x. Make sure x is the first number you look at on the left, and then y is the second number. So let's try the other point. B is 5. Okay, 5 on the x-axis is here. I'm going to line it up with -1 on the y-axis, which is here. So it'd be right at this point here. There we go. I think that's lined up with 5 on the x-axis and -1 on the y-axis. All right, how about the next one? C. -3, 3. All right, where's that guy? -3 on the x-axis is off to the left. 3 on the y-axis is up, so it'd be right here, I think, huh? C. Looks good, all right. Sorry if that's kind of hard to see. Get it? See? Okay, that was pretty lame. There it is. All right, next guy. D is 0, 4. Okay, so 0 on the x-axis means I don't go left or right. The 4 on the y-axis means I go up to 4 on the y. And that's point D. The next guy, what do we got? E, it's -7, 0. So I'm going to go over to -7 on the x-axis, but on the y-axis it's 0, so I'm not going up or down any. I'm just staying right there. That's E. Oops, sorry. E. There we go. That's the guy. And then last one is -6, -5. Where is that guy? -6 to the left. Okay, that's here. And then -5 down 5 would be here. All right, beautiful. I think we got it. A, B, C, D, E, F. Yep, that's it. Good job, everybody. We did it. Yay. Okay, calm down. How about the next one, number 51? This one seems too good to be true now that we've seen things way more complicated than this. Is the point 1, -2 a solution to the following linear equation? And the linear equation is 3y minus 2x equals -8. So you probably either overthought this or you got it right. I don't know. But just don't forget, though, that when they give you an ordered pair or a point, they give you x first and then y. So I'm putting 1 where x is, which is second, and then -2 where y was, which is first. That's the only thing I might mess up on this one, is I might mix the two up. Y was -2 and x was 1. So I'm replacing those guys, but leaving the 3, the -2, and the -8 the same. And then try to simplify that. 3 times -2, that's -6. -2 times 1 is -2. And that is true. -6 minus 2 is -8. So yes, that means this guy is a solution to that linear equation. Phew. All right, how about the next guy? Oops. Number 52, same kind of thing. Is the point negative 3, 0 a solution to the linear equation y equals 2x plus 7? So know that negative 3 is the x value, 0 is the y value. So 0 is going where y was, and negative 3 is going where x was. But everything else stays the same, equals 2 times that plus 7. So 0 equals, that's negative 6 plus 7. Nope, those do not add up to 0. It's a no. That means this guy is not a solution to that linear equation. No! Alright, we're almost done with this part here. Whew. How many more? So many problems. It's a lot of practice, which is good, but hopefully it's not too overwhelming, because it's just almost too much practice, but too much practice definitely makes perfect, I think. So number 53, they want us to graph a linear equation by plotting a few points. Okay. So remember, on these ones, it's too much freedom almost. You can pick anything for x or anything for y, whatever you want. I don't know, it's up to you, but yeah, it's almost too much freedom here. You can let x be something or y be something. I don't know. What do you think? Let's just do it. You can let x equal 0. I'm going to let x equal 2. Let x equal 4. Whatever. No matter what you pick, I don't know, the answer might be kind of ugly, but it'll work itself out, don't worry. And you know, if you ever pick a value, I don't know, something for x or something for y, and then you end up with, I guess, for example, what if I plug in 0 for x, and somehow for y I got something huge like 20 or something, I don't know, let's say. And you go over to plot that point 0, 20, and you say, uh-oh, this graph only goes up to 10. Well, feel free on a midterm or whatever it is to extend. Like, you can go, all right, I'm going to make this graph taller here, and I'm going to say this is 20. Yeah, if you get a point that's not quite on your graph, completely feel free to make the graph taller or further to the left or further to the right. Yeah. So just so you know, I don't want you to feel like you're trapped in this little tiny graph here. But okay, if I want to find these 3 points, I'm going to have to take each of those. So for example, the first guy, I said I want to plug in x equals 0 and substitute that in here and find y. So if I do that, x minus 3y equals 12, I'm replacing x with 0. And you know, I replaced x with stuff, but you could have replaced y with stuff, and that would have been fine too. So 0 minus 3y equals 12. But 0 minus anything is just that thing, so there's not really any need to leave the 0 there. And now I can solve for y by dividing by negative 3. So y must be negative 4. Alright, that must be my y value of that point. Okay, now I have to do that 2 more times. 1 for x equals 2, because I chose that, and then 1 for x equals 4. Alright. Well, of course you're replacing them in the same equation here. Minus 3y is 12. So first I put a 2 in for x. I don't know why I picked 2. Just because I'm weird, I guess. I'm not sure. Oh, why'd I put a 0? I'm losing my mind. Oh well. So if I have a 2 minus 3y equals 12, I need to isolate y to figure out what y is. Move the 2 over. Then negative 3y is 10. So you notice now when I divide by negative 3, I'm not going to get a pretty number. Y is negative 10 thirds. That's not very nice. But you know what you could do is make that either into a decimal or into a mixed number. So if I make 10 thirds into a mixed number, 3 can go into 10 3 times with 1 left over. That means this is the same as negative 3 and 1/3. That's a little easier to find, I think, so I'm going to write that instead. Negative 3 and 1/3. So don't worry, if you get a fraction, it's not too big a deal, and you don't have to graph it perfectly, because it's really hard to find 3 and 1/3 exactly. Just as long as you're in the ballpark, then that's fine. Alright, last guy here. I put 4 in for x. 4 goes here. And then I'll solve for y. Move the 4 over. Negative 3y equals 8. And when I divide by negative 3, I get another fraction, but that's okay. I can divide. 3 goes into 8 at most twice with 2 left over, right? Yeah. Yeah, okay, so 2 and 2/3, but also negative, so don't forget that. So that's that last value, negative 2 and 2/3. Whew, and if I plot those 3 points, I should be good. So my points are 0, negative 4, that was the first one. Where's he? Over here. No. Okay. Second point I found was 2. negative 3 1/3. Okay, so I'll go to the right 2, down to negative 3 1/3, which is a little lower than negative 3. So don't worry about it being perfect. As long as it's between the correct two numbers, then you're good. The last point I found was 4 comma negative 2 2/3. So 4 to the right, and then down 2 2/3, and let's say that's about here. Sure, and those look like they line up in a line, right? Don't worry about making it perfect. I think that's why you kind of show your work up here, you know. Look, these are the points I found. They're correct. I'm terrible at drawing. Yeah, don't worry about that part. That's fine. Hey, let's try another one, just for good practice. You got negative 2x plus 3y equals negative 18. Oh, I forgot to put x and y here. I guess that's unspoken. And you can choose any x you want or any y you want. It's up to you guys. I don't know if you want to... doesn't matter. I always like 0, though. That's my favorite. 0. And then you can pick, I don't know, 1? You want to pick 1? Sure. Who gives a crap, right? And negative 3? I'm feeling wild. I know I always pick x values for some reason. I think just because it's... I don't know. The more freedom I have on these, the scarier it gets, I guess. So I like to pick x values just because. It doesn't matter, though. You can pick y values. You can pick anything. So I'm going to plug 0 in first, and then I'll see what y is there. I'm going to plug it into this. Negative 2 times x plus 3 times y is negative 18, but I want to put 0 where x was. And that's the beauty of 0. Negative 2 times 0 is 0, so it's just 3y equals negative 18. And I can solve for y pretty easily by dividing by the 3. And thankfully, at least one of my values is a whole number, negative 6. That's good. Okay, let's try the next guy. I chose x equals 1. Let me see how that goes. I'll put a 1 where the x was. In this original equation, negative 2x, but I have negative 2 times 1 plus 3y equals negative 18. That's negative 2 plus 3y equals negative 18. If I solve this for y, I'd have to move the 2 over first. That'll leave me with 3y is negative 16. So I'm not going to get a nice value, but oh well. I can still make it a mixed number. Negative 16 over 3. See, 3 can go into 16 at most 5 times with 1 left over. So it's negative 5 1/3. That would be the y value. There we go. Alright, last guy. I'm trying to plug in x equals negative 3. I don't know why I chose that value. I guess I was just trying to be weird. I don't know. I think it's probably best to stay close to 0, you know? Like I chose x equals 0, x equals 1, x equals negative 3. Those are fairly close to 0. Usually you don't get in too much trouble and your points won't be too far away from the graph, you know? You won't have to go off the beaten path or draw the graph larger than it was before. Usually. Alright, I'm going to take the same equation but replace x now with negative 3 and see what happens. You got negative 2 times negative 3, that's positive 6, plus 3y equals negative 18. Now if I solve for y, I'd probably subtract 6 first. Let's see, negative 18 minus 6 would be negative 24? Wait, is that right? No. Yeah. Alright, I think we're getting lucky here because look at this. 3 divides unevenly. Yay! Negative 8 times. Yay! Awesome. Oh, hello. Hello. Whoa, 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 whoa. That's our y value, you guys. Alright, let's see. And you know, we've said before, you really only need 2 points when you graph a line, but plotting 3 points, it kind of makes sure that you're doing it right, because if those 3 points line up in a line, like last time, they kind of lined up, that means I must have done it right. But if I have 3 points here, and they don't make a line, that means you made a mistake. So it kind of catches mistakes before they, I don't know, before they become a big problem. Alright, what's the first point? 0 comma negative 6. That's down here. Okay, I got you. Okay. Next point, 1 comma negative 5 1/3. So I go to the right 1, down 5 1/3. So that's pretty close to the last guy. And my last point, oops, I should have written that. Now you don't have to write it out, it's just in case. The last point, negative 3, negative 8. I'm going to go to the left to -3 and then down to -8. That's way down here. I think those kind of look like they're in a line, right? Yeah. That's good. Alright, yeah, but if one of those didn't line up, like, wait, those three don't line up in a line, you better check your work. It's somewhere in one of these, and that's the sad thing, is you don't know which one's the wrong one. You made some kind of little error, so be careful there. Whew, okay. So section 3.3. Now we're graphing linear equations by finding their x and y intercepts. So that's probably actually my favorite way to graph a line. I think it's the easiest, but it's kind of, if it's been a while, it's hard to remember. But to find its x and y intercepts, you just, for x intercepts, you let y equals 0 and solve for x, and then to find the y intercepts, you do the opposite. Let x equals 0 and solve for y. So really, when you create this little box here, you're just going to let y equals 0 first, find out what x is, and then let x equals 0 and find out what y is. So we did this in the notes, but if you just kind of memorize that little box right there, 0's on the diagonal, and then you have to fill everything else in, then you're going to be fine. No problem. Doesn't matter which one you do first. I guess I'll let y equals 0. That was the top row. So I got y equals -10 plus 5x, but I want to replace y with 0. And there's y there, so it'll be 0 equals blah 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 blah. Now if I want to solve this for x, I better try to isolate x by adding the 10 first. If I add the 10, it'll be 10 equals 5x. And thankfully, 5 goes into 10 evenly, that's nice. Divide by 5, so x must be 2. Oh, yay, wee! Yay, you guys, yay! Okay, it's not that exciting, right? Of course it is. Alright, that's one of them. The other guy, I think this one will be easier. That last one, y equals 0, was tough, but x equals 0 is going to be easy. What if I plug 0 in for x? The original equation was y equals -10 plus 5x, but what if x was 0? Then that's going to make this really nice. 0 goes where x was. Y equals -10, that'd be plus 0, so just really -10. That's it. So the only downside of this method as opposed to the method we just did in the previous two problems is here you won't catch any mistakes because you're only plotting 2 points. So you got to be really confident in the work you just did. Don't miss any negatives and add correctly and be really careful. So the previous method, it takes longer, but it's probably better as far as you're not going to make as many mistakes. So here are 2 points, 2, 0, and then 0, -10. Just connect them, and notice my line isn't even straight. Don't worry about that. Just do your best, you know. It's not an art class, so don't worry too much. Alright, number 56. Yay! Yay, you guys! We're almost done! Whee! Calm down. So I want us to do the same thing. I'm just going to set it up a 0 on the y, a 0 on the x, and then try to find either one. Okay, might as well start with the first one. Y equals 0. I'm going to substitute that in here. -4x minus 3y equals 8, but y is going to be something else. Why does my x look so weird? It's freaking me out right now. I can't handle it. There we go. Okay, y is going to be 0. Let me simplify this baby here. -4x minus 3 times 0 is just 0, so it's just gone. Get it out of there. Now if I isolate x all together by dividing by -4, that'll be a winner. And that's a nice whole number, yay! You gotta take the little joys in life, you know, especially when you're taking a math class. So there are not a lot of joys in a math class, so take them where you can. X is -2, yay, whee! Alright, calm down. And now the last point, or the second point, we're plugging x equals 0 in and seeing what happens to y. So start it out, -4x minus 3y equals 8, but we're replacing x now with 0. Alright, if 0 goes for x, then that whole term disappears. You're just left with -3y equals 8. And now we can solve for y by dividing by -3. Dang it, it doesn't go in evenly. That's okay. I guess we're used to that as far as the other problems, huh? -8/3. Ah, well. And that'll probably be easier if I make that a mixed number. 3 can go into 8 twice with 2 left over. So this is negative 2 and 2/3. All right, that's my last point. Negative 2 and 2/3. All right. So the first point we found, negative 2, 0. That's off to the left. And then 0, comma, negative 2 and 2/3. That's down here, somewhere between negative 2 and negative 3. And that's it. Connect those babies. Bada bing, bada boom. Beautiful. Whew, almost done. All right. These guys here. Okay, okay. Let's graph this line. Y equals 5. Okay. So remember, these guys, when you have y equals something or x equals something, they only have one variable. That means it's either a vertical or a horizontal line. So it's hard to remember, but I always think of it as, okay, the x-axis, is he vertical or horizontal? X-axis is horizontal. And the y-axis is vertical. Vertical. So the lines, they're kind of the opposite. When I see, so for example, the y-axis is vertical. When I see a y equals something, it's horizontal. So it's kind of the opposite. When you think of the y-axis versus the x-axis, the lines y equals or x equals are the opposite. And in this line, x equals something, that's the opposite of the x-axis. The x-axis is horizontal, which means this guy will be vertical. I think that's the hardest part, is just remembering which one's horizontal, which one's vertical. Once you remember that, then, I don't know, not a big deal. So now you just think of it, okay, y equals 5, that's a horizontal line through the number that you see in your equation, 5, on the axis that you see there, y-axis. Let me find 5 on the y-axis, here he is, and then just draw a horizontal line through it. Whee! So really, these are the easiest lines to graph, but they're the hardest to remember. So you might want to make a note of these. If you haven't already memorized them, make a little note somewhere, like on your note card or something. And the last one, x equals negative 3, that's a vertical line through that number, negative 3, on that variable, x-axis. So I just find negative 3 on the x-axis, he's here, and then draw a vertical line. Whee! Whee! We did it, you guys! Yay! Okay, calm down, right? That was fun. But let me know if you have any questions, like the explanation didn't make sense, or you're getting a different answer and you don't know why. Please let me know, because that's really frustrating for you, I know. I've been there, definitely been there, done that. So thanks.